Well, hello out there, everybody. It's good to be back. Takeo After Dark makes its triumphant return to the airwaves. I guess, are these the airwaves? These are the wire waves? I don't, to the World Wide Web. We have made our triumphant return to the World Wide Web for
The
winter
interwebs.
session.
Yes.
Interwebs, that's right. This is Takeo After Dark, the Winter Essentials. I'm John Barba, and I'm joined by my colleagues, Dave Holdorf down on Long Island, and Rick Mayo out in Mesquite, Nevada, no, Arizona, no, Mesquite,
Nevada.
Nevada. There we go, Mesquite,
Nevada.
Nevada. One of
Not
those, one of
Texas.
those, one of those square states out west. There you go. And from a rounded state in the Midwest, we have Tim Ward from Mechanical Hub joining us. How you doing, Tim?
John, Dave, Rick, good to be here. I know John Mason Brink is around here somewhere, but on behalf of Eric, John, and I with Mechanical Hub Media, we are very excited to do this 6 weeks with you guys. The last couple of times have been awesome, so we're looking forward to round 3.
There we go. This is actually technically it's round 4 because we did the
Or
spring.
actually, it is round 4, isn't
Yeah,
it?
we've hit. This will be our final season. We've hit all. Not our final season. This is our 4th season, and we're going to keep doing this as long as things keep going. I mean, as long as there's an appetite for night school, we'll keep doing this. And it's been one of the cool things that I've seen out there is it's Takeo After Dark is being imitated. A lot of people are doing the same thing, and that's just cool. That's a very cool thing, and we're glad you guys are with us. We had 417 folks register for tonight's session, and I'm hopeful a good healthy chunk of you will actually be able to make it because that is terrific. You'll notice, look at this. We have matching shirts now. Huh? Well,
It's
there we go.
official.
Right, matching official Takeo After Dark shirts. And one thing we will be doing a little bit later on tonight at random, we have Takeo After Dark t-shirts that we will be giving away to our random people. And if you want to be less random, that's going to involve getting involved in conversations and asking questions. So we'll be giving out some of those later tonight, as well as a big grand prize package. We're going to have a grand prize package every week for our attendee of the night. So that's going to be all kinds of fun stuff to look forward to this evening. Tonight's topic is going to be on air and dirt removal and control in hydronic systems. And why is that important? It's something we often tend to gloss over a little bit, but we're going to get into that beyond ankle deep. We're going to get into it neck deep. So you guys really understand the importance of all of that. And we'll be starting our presentation momentarily. Real quick, I'm seeing a lot of folks already type in something. I just want to make sure you type in a hi, hello, how are you? That would be terrific. That way we know you can hear us, and that's going to be how you ask questions. So why don't you guys do that? And while you're doing that, I want to throw it to Tim, just to let you guys know what's going on in the world of Mechanical Hub. We're kind of doing this together, and I'd like you guys to get to know Mechanical Hub because Mechanical Hub is one of the coolest websites out there. So let's see what you got going on this week, Tim. I hear
John,
there's an
thank you very
awesome
much.
podcast, by the way. I mean, incredible podcast that you have available.
If you've not listened to our podcast, we've got 2 different podcasts. Both John and I do our Not Dead Yet podcast, which actually airs every Wednesday. So wake up on Wednesday mornings with John and I, go to bed with Rick, Dave, and John at night on Wednesdays. Eric and our friend Andy Mickelson do the Make Trades Great Again, which is a fun listen to every Friday. Gets the week ending right. Other than that, I mean, go check out our websites, hydronicshub.com or plumbingperspective.com or our mainstay mechanicalhub.com, as well as our social media channels. Our audience is key to us, and, our partnerships with Takeo has been critical and very, very, very rewarding for us. So anxious to get this 6-week program going, and with the audience numbers that have registered for tonight, it's off to a good start.
Absolutely, yeah. It's we're really psyched. We're glad to be back in the saddle again, as Steven Tyler and Rick Mayo have sung repeatedly. And so let's get started. I'm going to turn it right over to Dave, who's going to be taking the con tonight, and then Rick and I will be helping out watching the watching the questions, and we'll be getting to all of your questions. Like I said, we'll have questions. We'll talk about some of your questions as we go through the program. But at the very end, we'll stay on as long as you guys want to stay on to answer whatever questions you may have. So Dave, take her away, my man.
Alrighty. So excellent. So glad to see everybody joining. So yes, so yes, our resident Bruce Campbell, our host of Take-O After Dark since the very beginning. Just a little cold out there in the cold, and found some woman to make him mittens from Vermont. So how could I not do that, guys? How could I not get Bruce involved? So anyways, where was I going? What was I starting with here? You got me all messed up there, John. I saw you fall apart there. So, oh, I was saying, ask the questions all during the presentation. We don't do question and answer periods in case you haven't been here before. So type them in there. John and Rick are paying attention to those questions, and we will either stop once in a while, or the question may be coming up. John knows where this is going, so he'll keep it going from there. So tonight we're going to talk about air and dirt essentials for our first session here, and helping get the air out of your systems, and also taking a look at dirt and magnetic separators in your systems, if you really do need them or not. That conversation happens way too often, I think. So I want to make sure we bring that conversation to the forefront, and really shine a light on the magnetic dirt separators that we're putting into, or even talking about putting into systems. So, whoops. There we go. So for those of you that may be new, let's take a look at how to talk to me and John and Rick here. You're going to see a control panel. And if you don't see this expanded control panel that you see here, that means you want to pay attention to that arrow right there. So you want to click on that arrow. It'll expand out. It'll look like this. All right. And then down here at the bottom is where you're going to see where the questions are. Okay, if there's any handouts, you'll see the handouts there, which there should be a couple there. And also, if you're having any sound issues, this is how you control your sound, making sure you have the proper thing. Now, everybody will be muted because we are expecting quite a bunch of you guys tonight, so, and ladies. So that's the way you communicate. Type the questions in. You see a bunch of people already have. So that's awesome. Thank you very much. As we go through the evening. If you are watching this on a mobile device, things look a little different. There'll be a tab, a control panel, basically right there at the bottom of your device that you're using, and you jump in between, taking a look at the cameras or the PowerPoint presentations and the question section. So take a look there. So, oh, I do have that screen up here. Here you go. Here's what it looks like on a device. All right. So with that being said, let's talk about air in a system. All right. And air is one of those things that we just hate in a hydronic system. We've got air in it. We've got a lot of issues. And it's not just having air in there. I mean, I consider it, the bane of our existence in the world of hydronics. We got to get this stuff out. Hate having it there. So, but let's take a look at what air is going to have in there. And some of the things obviously coming from us here at Take-O. We take a look at it a lot of times from the pump side of things. And if you have air in a system, you can reduce your pumping capacity when you've got air in a system. And when you see this air bubble on the side here, I want to point out a couple of things. When you hear the discussions about bubbles and air elimination out there, all right, we talk about macro bubbles. Those are the big slugs of air that you have in the system. And that's what we typically purge out. All right, when you purge a system, you purge out the macro bubbles. Small bubbles are then going to be removed by your air elimination devices, and micro bubbles are not things that you can see. You cannot see micro bubbles. Micro bubbles need to be taken out of solution. All right, and even if we put in what we call micro bubble removers, sometimes they don't get them out if we don't put them in properly, based upon other things in the system itself too. So, and also when we think about pumping the water around, moving that water around, when you've got air in your system, the water's not going to move as fast for you. All right. So if we don't have any good air elimination, circulators don't pump air. All right. We circulate water. Okay. So we're not going to be able to move it as effectively either. All right. So that's important to understand. One of the big things to help in getting out air in your systems itself is really how we pipe up our systems. All right, the way that we get out those micro bubbles is by having the lowest pressure of the water itself that we see in a system. All right, and we're going to see the lowest pressure in a system right on the suction side of the circulator, but also after your expansion tank connection. All right, that is going to be the absolute lowest pressure in your entire system in order to help get the air out. Once you have that lowest pressure, the micro bubbles can easily come out of solution. If we were to reverse this here, all right, if we were to reverse the circulator and expansion tank connection and air eliminator, if we were to pump into it, all right, that would end up being the highest pressure in the system, and it's going to be a lot harder to get your air out. So this is another reason we've gone through, and a lot of different Takeover After Dark classes have talked about pumping away and what it does for the circulator performance. But now let's take a look at it from the air elimination side of things. At this point too is also the hottest water in our system. Okay, so when we have the hottest water in our system, air comes out of solution easier also. So that's another reason why we want to take a look at putting our air eliminators on the supply side coming out of our boilers and pumping away at the same time. All right, whoops. All right, so that's what I mean by the lowest solubility is going to be pretty much right at that spot. All right, your length of pipe that you have in between your air eliminator and your circulator is going to be the lowest solubility. Let that air get out of solution. We do not want to pump it around our system itself and keep it in there. So we take a look at some information in here, and these are some curves based upon the temperature of the water, the pressure of the water, and the solubility of air. All right, and obviously we want to be as low as possible. Now this chart is showing you PSIA. All right, so that's atmosphere. So our pressures are going to be a little bit higher. All right, let's take a look at a system at 180 degrees and 12 PSI, which would be about 24 PSIA. All right, and when we punch it in there, we see the solubility of the water, of the air in water is just about 5%. All right, that's good, nice and low. All right, the higher the pressure, the more soluble, even at that same temperatures, the more soluble that water is going to be, and it's going to stay in solution. So, so we want that that pressure where we want it to be, as low as possible on the suction side of the circular. I hope that makes sense for everybody there. So before we even get into the different designs of our air eliminators, let's go ahead and take a look at just getting the air out initially. All right, so air eliminators, I feel they're worth their weight in gold, depending on how you put them in the system, because nobody here, I'm assuming, enjoys purging, right? There is no enjoyment in purging, unless it was a really hard day and you got to sit on the bucket for a little while you're purging, but nobody really enjoys it. But let's take a look. This diagram that you see here comes with every circulator that we have. Every circulator you ever had, this is in that instruction. And I want to talk about this for a second in helping you purge your systems out easily and effectively. So the instructions also show up in there. So let's talk about the key that you have here. So here you see valve 1, valve 2, valve 3. Those are shut off or isolation valves that we have in here. So you have some isolation around your circulator. We've got a valve on the return side as your valve 1. We have our fast fill, our POV system in there. And here is the steps in order to do that purging purposes. All right, how's the best way to get there? So the first thing we want to do is close valve 1, the drain valve, and valve 2. All right, so close those 3 valves down first. And if you had multiple zones on here, then we're also going to close those valves at the same time. All right, and just purge out that one system, that one zone that you have in there. So let's make sure all those zones are closed off. Then what we're going to do is open up your valve 3 going out to your system. Make sure that valve is open. Open your fast fill and your drain valve. All right, and nothing's going to happen just yet until we open up our supply zone, and then we're going to start getting our flow. And if we start taking a look at this, we're trying to minimize the direction. We want the water to go through all of the pipes throughout the system itself. So here it's going to head through the system, then come back and out our valve. All right, out the drain valve of the boiler itself. So the boiler itself may have its own air vent on there in order to get it out. So we will fill up in there first, and then we will start pushing through the system in order. And if it's maybe you just have your basic purging steps first, really help get the air out first. Let the air eliminator do its job later. Here you want to get out the macro bubbles. Your air eliminators are going to get rid of your small bubbles and the micro bubbles. All right, but you got to get those macro bubbles out first. Otherwise, we're just not going to be able to move anything throughout the system itself. All right, so I hope this helps you guys take a look at this as we go through. And as you install systems out there, remember, like I said, it's in the instructions. I'm sure lots of people have put in many circulators in the past, so you haven't really read these instructions to their fullest. And I have found this to be incredibly helpful for a lot of people. I show this to a lot of new people that are getting into the trade, and once they see this, it really helps make their life a lot easier in getting started, getting that thing flowing. All right. So how do we get the small bubbles and the micro bubbles out of the system itself?
Hey, Dave.
So we're going, yes.
You got a question relative to that drawing you just had on there. And Philip's asking, why do you close V3, valve 3?
Well, if he's talking about these valves down here, this zone is closed off. We started off with all valves closed and then opened them up.
Okay.
I think that maybe what he's talking about. This is the first valve to open up was up here. There's a second valve 3 in the diagram for a zone pump application. If you had zone valves, you have the isolation on either side of your circulator, and then you're going to open up your zone valves manually and then follow the same steps for each zone at the same time. And if we kept valve 3 closed, we want to make sure we're not sending water backwards through the system either, right?
There's another one here, Dave, as well. A lot of people get hung up. Some of the drawings show you entering the fast fill at the bottom of the air separator, and it's not always the case. And so Andrew's asking, why isn't the fast fill at the expansion tank? In this particular picture, it's not. Doesn't have to be, but elaborate if you want to, Dave. That's a question.
I'll let you take off on that one, Rickster.
Just again, we can fill the system wherever it works. And this particular picture is what David mentioned is what's sent out with all of our circulators. So again, there's 6 ways to skin a cat, but just understand that the fast fill doesn't always have to be at the expansion tank. And we've actually done some sessions on that and talked about how that works. But in this case, just not drawn that way. If Dave would go back a couple slides, and I don't want you to, Dave, but as we showed that kind of a color drawing of pipes and that sort of thing, you would see, well, go back to right there, okay? So for instance, that is located there, and the way that that's set up is, I guess our industry has coined it as a power purge. It just means that instead of having the valve on the return side of the boiler like Dave's drawing showed, this is actually making the assumption that we're going to purge everything, including the boiler, through that last purge valve that you see on the right-hand side of that ball valve. Yeah. So again, there's lots of different ways to do it. It would be, I kind of think a picture's worth 1,000 words. If we could throw up several drawings and show you all the different ways it can be done, I think it makes it a little bit more pointed. And maybe we'll do some of that as we go down.
Right.
Do some more training sessions.
Yep. So yeah, I was going through the instructions that come with the circulator. So actually, if you were to take that drain valve that we showed you before and move and use this one instead, yeah, now you got every bit of pipe. The only thing that's going to have any air in it is going to be really right here. All right, that you're going to pull the water in. It's the water's coming in, going out that way, going throughout the system and coming back over here. So you just have this little bit that's going to flood out. You've already going through the boiler itself. So like Rick said, lots of different ways. That drawing we've had there probably for 50 years, I would assume. So excellent questions. Thanks everybody. All right, so let's talk about getting out the small bubbles and the micro bubbles. All right, and let's talk about the air scoop. And I know some people look at it saying, "Oh my God, if you're using an air scoop, that's old technology, man." You know what? What's its job? Is to help get the air out, and just having that understandings behind it. So we want to take a look at this for a second. So you've got a couple of basic components here, but I like to talk about it because the principles of this device also follow suit as we start taking a look at other air elimination devices in our system. So the basic principles are sound on here. Couple things I like to pay attention to. All right, one, we got an arrow on here. All right, the arrow is telling which way the water goes. All right, we do have that printed on the inside so the water can see it. All right, on the outside the water can't see it, so we put one on the inside too, so the water knows which way to go. I'm joking, obviously, but one of the things to pay attention to, we got the word inlet in here. When this is installed, the words that are cast into this thing should be easily read. All right, that's important. You want to make sure you can read those words that are in the cast, because when it goes in like this, it's not going to work as effective. All right, and some of you out there are like, wait a minute, what? How did he even get that thrown on there? All right, with the tappings and whatnot. So this is not doing a job. This is just an expensive coupling at the moment. All right, it's an expensive expansion tank holder. All right, so these are very basic, simple devices. All right, there's no moving parts inside. There's a scoop. Basically, there's a scoop on the inside to help move that air out. All right, we throw our high vent on top. All right, and I'm going to talk about these things also tonight. All right, and like we were showing before, expansion tank on the bottom. Okay, so how's this thing work? Well, one of the things to pay attention to is this is all going to be filled up with water, right? And so is our pipe. But we have as the water comes into our air eliminator, the scoop in here, once it passes this point, right past here, the velocity of the water must slow down, because as it comes into it, it's got to spread out throughout the entire device. As the velocity drops, air is going to come out of solution a heck of a lot easier. So that's why we have that big shape to it, that big bulb in there, in order to help get the air out. So that's design is on purpose to do that. Now, another thing that must be important when using a basic air scoop like this is having the proper flow into the system. And in a closed loop hydronic system, we have two types of flow. All right, we have laminar flow and we have turbulent flow. Turbulent flow, you know what that is. That's all churned up. That's all mixed up, the water. And think about the water molecules themselves, so to speak, or big water droplets that are in the pipe itself. And they're all churned, all right? And the way they get churned up is when it comes to a fitting, comes to an elbow, comes to any type of connection, is going to move around and get all mixed up. What we want is laminar flow to occur here. And the only way we're going to get laminar flow to help get the air bubbles out is to have 12 to 18 inches of straight pipe feeding into this device. All right, then we will get laminar flow. What ends up happening is that you will get the air bubbles are going to start to, so to speak, align themselves to the top of the pipe and not be churned up. And when they come to the top of the pipe and they enter into the air eliminator, they slow down, they come out of solution much easier. The bigger bubbles, like the small bubbles, are going to get scooped. All right, the scoop in there is going to push them towards the top. The small bubbles, the micro bubbles, will then adhere themselves to the surfaces in here. All right, all the different surfaces around the scoop itself and the scoops, you're going to get all the micro bubbles. And when you get two micro bubbles next to each other, what ends up happening? You get a small bubble. All right, and once you get a small bubble, then that's going to float up to the top, and then the vent is going to happen. All right, and Kelvin, yes, straight pipe never happens in the real world. I agree. It's not easy. It's not easy to get the 12 to 18 inches of straight pipe in here. But this is, in order for this to work the way it's supposed to, the way it's designed, all right, is how it's going to get it out there. So if you've noticed, if you have systems out there where, you don't have that 12 to 18 inches of pipe, a straight pipe in there, you have an issue. Sometimes it's hard. You spend more time purging. And remember this part about purging. All right. The more you purge, the more air you're introducing into a system. All right. 60-degree water coming in from the street contains up to 4% air. You're still going to have air as you're bringing in more water into the system. So you still need to get that, still going to have some air, some micro bubbles in the system itself. So we still got to make sure we get that out of there. So don't keep on purging. All right, yeah, purging is going to get rid of the macro bubbles. Let the air eliminators do their job, okay? So that's important, but got to have that 12 to 18 inches in order for this thing to work effectively. That's the word I'm looking for.
And that's the 12 to 18 inches for the scoop. If you don't have the 12 to 18 inches, we have other options, right?
Right. We do have other options, which I will get to that in a minute, okay? Or in a couple of slides from now. So while we're talking about the high vent, I want to go into a little bit of detail on these things, because if we don't pay attention a lot of times to these things, and these things are considered consumables. All right, people are putting them in, you throw them out. You go and do service on a job site, you rip them out every single time you're putting new ones in there. So I'd like to talk about them for a second. There's a lot of different ones that we have: 1/8 inch, 1/4 inch, 1/2 inch, 1/2 by 3/4. All right, now the little tab sitting down on the bottom, this is what we call a bubble breaker. All right, what we mean by a bubble breaker, it ends up in the system itself, and any large bubbles that are going by, all right, it's going to collide with it and hopefully separate them to send them up to the air vent to let this thing collect it. All right, so that's that little tab sitting down there. It's going to help you remove some of the air if you're putting this in line on a pipe. All right, if you've already got it going onto, say, a scoop, then obviously we're not going to be breaking too many bubbles at that point. All right, they're going to be slowly floating up to the surface there. Now, this is also something else I wanted to point out. All right, one of the things that we don't have on here is a Schrader valve. All right, on here, and that's an important thing to pay attention to. I've run into a few of these that have Schrader valves, and I'm sure we've all touched them that have it. You take the cap off, you press on it to get the air to come out. All right, you're thinking if there's any air that's stuck in here, we're going to press on it to get that air out, and then all of a sudden, is the water still dripping out? Right, and you're like, oh crap, I shouldn't have touched it. You know, it was an older one, I shouldn't have touched it, but I did, and now it's dripping, and I'm going to hope it dries up and goes away. Why is it dripping now? Well, that Schrader valve isn't seated properly. It didn't get a good seat, because this is the surfaces of right at the top of this cap is where all the crap that floats in our water is going to end up. All right, it's going to end up here, and sometimes it's going to foul up the mechanisms that we have in here. So I've taken mine apart so we can really pay attention and see what's going on in here. And I do have some close-up pictures that I can show you on the presentation. So if you wanted to look at the camera, all right, it's not a lot going on. It's just a little hinge and a float in between there, right? And back on the inside is where the sealing point is. But if you have a Schrader valve, yeah, they're a pain in the neck once they get clogged up, and yeah, you're going to go and take them apart and throw them away. All right, so here's what we're looking at inside. I also did a cutaway. So I did this for my buddy, Eric. All right, Arnie, he loves cutaways. So I did this in the garage the other day. All right, so Eric didn't join us. So Eric, you're gonna have to pay attention to the recording of the cutaway to see it here. So what I want to show you on the inside, and this is that vent, and this is a little rubber disc that sits right up against there. And that is our sealing surface. So you have a nice large sealing area rather than that Schrader valve with an O-ring that can get clogged up in there. So I'm not saying that this can't get clogged up, but hey, that's really easily cleaned. And that's just a straight throughput right there that goes right up to the hole underneath that vent. All right, so it goes straight through there. Now, I thought this was a really cool design. You know, once I take these things apart, we pay attention to them. And here's a cutaway of the float, and the float is actually hollow with 2 holes. So there's a little mini hole in here. So the air, you know, that comes floating up through here is going to help keep that vent closed. It's going to help keep it closed because you've got that air pressure floating up in there. Now, once it starts to get too much, then it seeps out through the hole coming through here, and then is going to push down the float. Okay. So that's what we're looking at. That's what we're looking at in here. So got a great statement from Joe Mattiello. He's our commercial guy. He worked in tech services for many years at Taco. And he says the Taco air vent is manual. not automatic. All right, Schrader valve brands and you know, it's you know, automatic options, you know, are challenging sometimes. You know, this is a good automatic design. Wait, I'm trying to read that again. I'm not sure if I'm reading that properly. So, but I thought this is a really neat design to help, you know, the air that you get in your system, and that air is going to stay there, is going to help keep that closed. All right, unless the air gets too much inside and help push it down. So, a couple other things I like to point out, and I know, like I said, people are replacing these things in droves. It's another little secret that we have that many people don't know we have. All right, is a check valve. All right, we have a check valve that you can put into the system itself, whether it's going to be on your on the scoop itself or in the system somewhere. We have an automatic check valve, so if you do have to take this apart, take it out of the system, clean it, replace it, we do have an automatic check valve to seal up on you. So what you need to do is basically pull out that bubble breaker. Really easy, just pair of channel locks. If you take a look at that bubble breaker, and let me see if I can get the focus. Probably can't get the focus in there too well. A little small. All right, there's nothing really holding it in there. You just pull that out, and then you throw the air, throw the check valve in there on top. Okay, and now you've got a check built in to your system itself, so you can easily pull these out. The part, yes, sir.
So Dave, Thomas Alvis asked what really amounts to a brilliant question just as you were going into the check valve. It says, he asked, why not make them with an integral stop to perform maintenance? And with your very next breath, you brought that up. So Thomas, kudos to you, my man. You asked what we in the industry call a brilliant question, because the question was answered by the very next sentence out of our presenter's mouth. So good man, good man.
So
there's a couple more questions here, but continue, Dave.
Yeah. Okay. So there's the part number for it. I like to point that out. So if you need to, if you're looking into getting one of them, or you want to start using them on a regular basis, all right, there you go. A couple of dollars and you got yourself a check valve. It's just spring loaded. And as you can see here, this O-ring is going to seal up against your vent itself. Now, if you have vents installed in a scary location, so to speak, in the house, all right, as in, if it drips, it's going to create damage someplace. All right, we don't want to create any damage anywhere. We have what we call a waste connector. And what this waste connector is going to do is you're going to pull off the cap in here, and this is going to change that metric thread to a straight thread. And then you can change that over to any pipe yourself. All right, this is going to be a 1/4 inch thread over here now. Got a gasket. So now you can go ahead and put on some soft copper pipe, bend it and vent and drain it where you want it to go, so it doesn't drip out in case anything does foul these things up.
Dave?
All right.
James
Yes,
Tamblin had just asked another brilliant question as you were getting ready to say those very words. He asked, can you attach tubing to the air vents to route incidental water spits to a drain? We've got the first class of the winter season. We've got 2 brilliant questions inside of about 2 minutes. So guys, kudos to you.
Wow. So that means the rest of the season
James and Thomas, very good.
So that means we can't do any better the rest of the year, the rest of the winter.
We just peaked. We just peaked.
So yeah, so you can go with copper pipe, plastic pipe, whatever you want if you need to convert it over there. Now, you know, and when it comes to the cap, you know, what do you do with the cap? You want to leave the cap open. All right. The cap has a couple of slits on either side. When you do it, you put it down tight. There is an O-ring seal on the inside, so you can tighten them down. All right. And then you give it 1 turn open. You don't want it to be wide open. All right. Give it 1 turn open. So this way it will let that air out. Now this is probably a more opinion than anything. All right. Me personally, if you had a brand new system, just installed, new boiler, major surgery that happened to your hydronic system, I would keep that vent cap open. After the first year, when you come back and do some service, you know, clean the boiler, whatever, make sure everything is good, my suggestion is maybe closing them. And I know a lot of people, probably half the people on here just freaked out. All right, comes to blows sometimes when I do this in a training class. I'm saying, close it. They're like, well, you can't get the air out. Where's it going? Let it stay in here. What makes what ends up having to be changed is these things all the time, because you come back the following year, open it. and go psst, and the air comes out, and close it again in case you you don't want to see these things all crusted up. All right, you want these things to last as long as possible. I know half the people in here just said, well, wait a minute, that's job security. You know, we want to make these systems as best as possible for our customers. That's why I also say check expansion tanks every year. They'll last a heck of a lot longer. You'll go ahead and keep that closed and open it up and go psst, let the air out. If there was any, if there's been no problems with the system, why would there be any air in it after a year? Okay,
Dave,
so just some of the things to think
you're not
about.
going to believe this, but James Tamblin asked, can you no, I'm sorry, Bob Dressler asked, don't you leave the cap loose so it can always vent air automatically? So there's 3 for 3, baby. There's 3
There
for
you go.
3.
So I think that's your choice. You make that choice. Me personally, I like to keep them closed and open them when we do the service. Some people, and if you have a vent pipe on there, I mean a drain pipe on there, then obviously you're going to leave it open. So those are your choices on what you want to do there.
Got a couple questions here for you. One, what is the depth the check valve adds? Asked Kevin McGowan. You got the sample there. It's an inch maybe?
Well, yeah, the bubble breaker is going to be a little longer, but this is also plastic. So if you were in a short piece of pipe and in a through pipe there, you could probably cut that down if it was going to hit.
Mm-hmm.
All right, if that's what you're talking about, that length there, yes, this is longer than the bubble breaker itself, but the entire check valve is going to add, I guess if you were close to a ceiling, when you install one of these things, you're going to add about an inch to your system.
Okay, very good. Patrick S. asked, can they be purchased by the truckload? Patrick, if you order them by the truckload, we'll send them to you by the truckload, brother. That's an easy one. In a multi-story, can these suck in air? Yes, they can, but see, this is an air letter outer, but you change some system dynamics, it turns into an air letter inner. It's a dandy air letter inner. In the parlance, it can be an air admittance valve. That has to do with your circulator. That gets into pumping away, pumping towards, creating a negative pressure, yada yada yada. I mean, that's a whole another concept that we can get into. But yes, they absolutely can. Under the wrong set of circumstances, absolutely can.
Have seen it plenty of times. Yep.
And that's when you close the cap. There you go, says David.
There you go. Right.
That's when you close the cap.
All right. So if we want to take a look at more enhanced air separator and designs, and obviously, the basic scoop has been around for 40, 50 years doing its job. And there's a lot of smart people working behind desks and computer screens that are making these things better and more efficient. So let's take a look at what we call the 4900. 4900, I call it is an enhanced air separator to really get the air out fast, quick, and easy. And what we have here is a design that, one, is not directional. So there is no arrows printed on the side of the air eliminator of our 4900. So you can put this in any direction as long as it's up in this direction here, obviously. Again, read the text. All right. If you have to turn your head to read the text at all, then you installed it incorrectly. So, and what we have in here is what we call a collision media. So we have what we call these Paul rings. So these Paul rings, these stainless steel rings, are just rings that are bent up and have a whole bunch of tabs bent over in them. And it creates a lot of stuff that's in the way. And when we start pumping water through that's got air in it, it's going to have the small bubbles and the micro bubbles. As the water enters the chamber, all right, and again, big chamber, low velocity, the water slows down, the air comes out of solution pretty easy, but you now also have the stuff in its way, and the water can change directions really fast to get to the other side, and the air bubbles are not going to keep up. All right, and they're going to glom onto all the surfaces, a lot more surfaces now. The micro bubbles are going to attach to each other, to the Paul rings. Then they're going to join each other, and then they're going to float up to this enhanced air valve, air removal valve now. So this float mechanism is a lot different. All right, it does have a couple of guides that you see in here. So there's a guide on the bottom just so it sits down properly. There's also a guide in the top here. Excellent question, Bob. Sorry, I forgot to bring that up. And actually, I jumped right past it. There is no pipe length of pipe needed. all right, you can come right off an elbow and tie right into this thing here. So because of the so much more collisions that's going to happen in here, and then as the air bubbles are going to scoop up, and then we are going to collect the air up here to push the float down. So this one does not have, it has a very small hole in the bottom to collect some of that air to help keep that valve closed. But we've also got some other designs added to it. And I see a bunch of questions coming through.
Yep. Drain, can we add a drain to the bottom? If you're not hooking up the expansion tank or the fill, you could.
Yes, we do have a tapping on the bottom of it.
Somebody was, when we were talking about that other location before, they were saying, yeah, they're worried about putting the makeup at a point where the pressure could change and drop to the point where it would let more water in. That's a given, right? That we want the makeup to be at the point of no pressure change, but that's where the expansion tank meets the system, not necessarily where the air separation device is. So again, picture's worth 1,000 words, but
yep. And we'll see probably a bunch of those diagrams when we come up to one of your classes too, Rick, right? A lot of piping diagrams. Yeah, we got a couple.
Yeah, if we're covering
later.
that.
Yep.
We had another question about, one was from Thomas Alves. Does this create measurable head? It has less head through that than through the same length of pipe. It's a big open space in the piping where velocity slows down. So actually there's less head loss through that air separator than there would be through a similar length of pipe. So,
well, we
no.
give you the CVs. You can calculate it. We can show you what it is. In fact, just give us one example. What size do you use quite a bit? Is 1 inch, inch and a quarter?
Yeah. I think it's what, CV at 27 on a 1 inch?
Yeah, well, a 1 inch is 24. Yeah,
24.
On an air separator.
Yeah. Again, less than the same length of pipe. So no.
Right.
Yeah.
Yep.
Very good. Is this available in press?
Yes, we do. We have a couple sizes in press. We have some sweat. We do have some thread in there too. Correct. Now the other big thing about this is that these pole rings are made out of stainless steel. So whatever water quality you have in there is not going to eat it up. There's a bunch of different ones that are out there that have a lot of steel media. They still do the job in getting the air out, but they also sell a lot of replacement parts. All right, because over time, if you had a glycol system, it's going to turn acidic, and it could start rotting away any of that steel that you had in there. So we made it all out of stainless steel. So I haven't known of anybody getting a replacement basket for here.
The upper portion,
as a replacement part.
Yeah, the upper portion, however, is replaceable.
Yes, correct. So the upper part you can replace. There is an O-ring seal. It is threaded on here. So if you can see right there, and I'll even show you, I've got a cutaway. Here's another cutaway for you. So you'll see there's a thread on the inside. There's your O-ring. So the top part does come off. You can replace it. You can see the mechanism on the inside. You can see that basket of pole rings on my cutaway in here. They're just randomly dropped in here, all right, to really create that collision media that you have.
Let me throw something out there, because hopefully you'll chuckle like I did. I had someone grab that one time and shake it like a maraca, and he was worried about it adding noise to his system. And I said, well, only if you're shaking it while the system's running. But hey, it was funny to me.
In a mobile home. Yeah. If you had a boiler in a mobile home, then yeah. And I want to take a look at another component of here. A lot of people don't pay attention to these enhanced air separators. You take a look at an air separator and you're like, all right, I'm more important about the collision media, what we got on the inside and how it's going to get the air out and stuff like that. But let's take a look at this shape in here. And if you notice, this shape is pretty unique, all right, in having this conical shape in here. There's a specific design to this. And one thing I want to point out is, all right, like our vent, all right, where we have a cap to shut it off if you don't want it to vent on its own, we have a little screw in here, all right, that you can shut down. And that's probably useful when you start purging a system on that initial purge, because then you start putting water and air through here and this thing starts bouncing up and down. And if this is anywhere near your face like this, you're getting a couple of spits in the face. All right, so I like to close it down. in the beginning, in the initial purge. So you have that screw out there, and then the outside of this is machined. So if you wanted to put a hose on here and tighten it down hose clamp wise for your drain pipe, okay? But the shape in here is designed on purpose to maximize the amount of air and keep air actually in the vent itself. Because of the valve and the hinge mechanism up here, we want to keep this relatively dry. So if we take a look at, say, the conical shape that we have here compared to how almost everybody else's and even our basic vents look, all right, you have a basic flat top in here. And because we have lots of oils and dirts and crap floating around in our water, it's going to form a film at the surface there. So what we want to do is, once the water level, the air level drops, all right, pushes it down, or we get that much air in here, is when we're going to open it up, and then we're going to close the valve and leave this much air inside so we can't foul up the mechanism on the inside. So we want this thing to last a heck of a lot longer, last the life of the system itself. Whereas a lot of systems, all right, that's about it. You know, they're going to get up higher into the valve mechanism and mess it up. So we have that shape to it on purpose. And here's that guide, as you can see, to make sure it rides true. And this guide that we have here at the top and the one at the bottom, make sure also, this is also really important. You take a look at our basic float, you know, in a can vent or any shape like this, the float mechanism is about the same size as the can. And if you get a little cocked on these things, as you can see by the float, it's now cocked, all right, and going to rub on the sides, and it's going to create a little bit of friction and maybe not move the way you want it to. And I know everybody out there is trying to make their systems as plumb and level as possible, right? Until you leave, and then everything just falls out of whack sometimes, right? They don't stay perfectly level. All right, so that guide on the top and the bottom, and because that float is not rubbing up against the edges, you don't have to worry about it hanging up at all. So just a couple of things that I'd like to point out that I thought the engineers came up with some really good stuff inside. I hope that makes sense for everybody. Any questions coming through?
I'll get a couple. One is, if it needs to be cleaned, how do we do it? Well, it doesn't really require cleaning, other than unless if something bad happens to it, you know, then it may need to be cleaned. But it's no more than any other, you know, similar type of air separator. It doesn't require more or less service in that respect. Again, any kind of cleaning would just involve unscrewing the top, checking that the pawl rings are okay, and then, you know, running a rinse through the upper portion would really be the only kinds of things you would ever do. But it's highly unlikely. I mean, I've seen these things installed for 10, 15 years and no one's ever touched them, and they work just fine. So it's not a chronic thing. It's, if something really weird were to happen, then maybe you might have to. But it always good to keep that in mind.
Well,
Terry
that goes
Turner,
into the second part of our class then.
there you go.
Tonight.
There you go.
Yeah.
Terry Turner asked about the performance of the 4900 compared to the Spirovent.
Well, there was an independent study that was done based on those pawl rings, and what was done, they studied the effect, or how fast the air was removed, and also how small of an air bubble removed. And what that study revealed was that the 4900 with the pawl ring design pulled out the 3 times smaller of an air bubble at the same time. So it is going to be worth its weight in gold, all right, in trying to get that air out. So, you know, just
Maybe the best way to
I'm
put
not saying
that
it's
is,
garbage. Spirovent
yeah.
does a great job in getting the air out. All right, we're just getting down to those smaller micro bubbles as we talked about before. As long as you are, go ahead.
No, I would say the Spirovent is a really good air eliminator. The 4900 is a really, really, really good air eliminator, and it's 3 times more and 3 times
yeah.
smaller. But you know, you're not, you know, again, you can't say anything about Spirovent. It's a terrific piece of equipment. This just does outperform it.
So as you can see here, you know, you don't have to worry about those minimum pipe runs on a couple of these projects. Here was a commercial job that we threw them in there, and here's a residential project. I got these from my buddy up in Peabody, Mass. It's Salem Supply. sent over some pictures to me. Just wanted to show off a couple of jobs that he had, so I figured, hey, I got to use them tonight. So, and we make this thing up to 36-inch in diameters, right? 36-inch pipe diameters.
We'll send you a
All right.
truckload of those if you want them too.
There you go.
There you go. Yeah, Patrick, you get a truckload of these. There you go. So so here they don't go the brass. We do this steel in our Fall River facility, and we have the same basket of pole rings. The pole rings just bigger. You look at these pole rings in here, and they're about a 3/8 of an inch diameter. When I look at the ones that go in these units, they're about that big. All right, of a pole ring and dropped inside there. So, and the same float mechanism that you see in here is also there. And these are also a high pressure mechanism that we have. So here we just have the basic float mechanism. If you wanted to get one of these, if you wanted to drop in a system, and then the ones that go on these 4900s, actually the float is longer and drops down inside the tank itself. And we have that along with the boiler trim kits. This one here has the 4900 involved in it. So if you're looking at boiler trim kits, that's going to get all your parts and pieces involved. You've got all that built in right here, and being able to have a check valve to also isolate your expansion tank and isolation valves.
Hey, Dave.
Yes.
Sean's got a question, and somebody else had asked already, and I just typed him an answer, but I'll say it in case anybody else is going to ask. They're asking about putting a ball valve on each side of a 4900. Well, I mean, if you want to add that much, it's not required, let's say that. And if you want to add that for serviceability, absolutely. You just add in a whole bunch of, well, a lot more man hours and more money for those, 1.25 inch, 1.5 ball valve. And so answer is not required, but you want to put more valves in there, go for it.
Yeah, it's kind of like, why would you put it? I mean, if you wouldn't put it in for a spiral vent or for an air scoop,
right?
Where you're likely to have more issues than you would with this. There's really no reason to do it with this either. It's just if you want to, you can. So there you go. And then another question came up about pressure drop through the device that we'd have to worry about. Again, the pressure drop through the 4900 is less pressure drop through a 4900 than there is through a similar length of full-sized pipe. So say you had an 1.25 inch 4900, there's less pressure drop through that 1.25 inch 4900, which is what, about 5 inches long, maybe 4 inches long. There's less pressure drop through the 4900 than there is through 4 or 5 inches of 1.25 inch pipe. So no. I guess that's the short answer there, Andrew, is no, there's no pressure drop to worry about whatsoever. It's less than a hunk of pipe.
When we look at I see a question that came in from Thomas also on the commercial ones here. We've got a lot of different designs. A lot of them come from specs from the customer on certain systems. You take a look at the one on the left here, and that's is an air eliminator. This one happens to be dirt separation also. All right, so you're doing your air at the top side, so that's why we have the pipe coming through the middle side of it. So we have an area for dirt separation, which I'm going to talk about next, coming into play here.
All right, and a couple other questions. Ed Kahn asked about, does the trim kit come in press? Not at this time?
It does not. Not at this time. Inch and 1.25 inch trim kits, correct. No press yet.
Right. The ones with the 4900 are sweat. The one with the air scoop is obviously threaded. And a question from Bill D'Agostino: if you have a Taco low loss header, do you need to add another air separator, or will that do a good enough job removing the air? That's a really good question.
So yes, the hydro separator is just that, a hydraulic separator. It is not doing any air removal. Yes, we put an air vent on the top to collect any air that may accumulate in there, but there is no collision media in there.
Right.
All right, so you are going to look at having your separate air eliminator if you wanted to put a 4900 in front of that, or even on either side sometimes too. So yeah.
Yeah, what we'll see in some of our big commercial low loss headers or hydraulic separators, there will be collision medium in there as well. In the smaller residential ones, ours specifically are designed to be a piping convenience item, and we did not go to that. We did not go that route with our low loss headers.
All right, so let's take a look at getting the dirt out.
Yeah.
All right, and water, and I'm not going to talk about water quality and chemicals and whatnot. You know, talk to the chemical people on those things, and you know, I know we've got an attendee tonight. He does a great job on it. So and take a look. Come back to our summer school, Takeo After Dark summer school. Go to the YouTube page and look for our water quality one that we did there. And Patrick did a great job on that. But if you think you have water quality issues in the system, there are enough indicators that are going to tell you what's going on. So you start thinking about your systems and they start looking like this on the outside where the pump seals are starting to leak. Now, yeah, we're not seeing a lot of our B&G 100s or the Takeo 110s out there any longer, but all right, that could be an indication of a water quality issue. Your IFCs, all right, I know a bunch of people out there that hate the IFC because they get stuck all the time, all right? And then meanwhile, we've got tons of people out there that say, I got no problems at all, they work great, all right? You might have a water quality issue, all right? And it's gonna be dirt and other things in there, all right? We're getting seized circulators prematurely, all right? You should get at least 15 to 18 years out of a circulator. And if you see you get circulators are seizing up prematurely, there's not a lot of tolerances in between impellers and casings and whatnot, so we need to pay attention to that. All right, zone valves get hung open, all right, and all of a sudden you got to bang it with a hammer every once in a while to get it closed, or you got to bang that circulator to get it started again. Okay, you might have water quality issues, low water cutoffs. You're getting false positives, all right, and they're tripping out on you. So we may have, you know, getting the sediment and whatnot and things like that going on to onto the probe going into your low water cutoff. So these are all indicators we need to start considering getting the stuff out of the water itself, all right? Or even the heat exchangers are starting to, and pipes themselves getting clogged, all right? And we start seeing a lot of our boiler manufacturers out there are requiring some sort of dirt separator to be put into our systems themselves. So I got these from a friend of mine from NTI, showing me a couple of heat exchangers, all right, that are getting clogged up. All right, boiler designs have changed tremendously. All right, where we went from our cast iron brothers to the wall hung sisters now. All right, the boilers are getting smaller. The heat exchange passages are getting smaller. All right, I mean, we take a look at this boiler there. That's 12 years old and done. All right, this is 3 months old. This is 3 months old. All right, where we're starting to see buildup on the heat exchangers. All right, as you can see here, we can see iron deposits, scale, visible debris that going to send up in the water and really start affecting the performance of the boilers themselves and the heat transfer that you're going to get, and also the failures of the heat exchangers going on. All right, and here we can see, and it doesn't matter what type of boiler it is, whether it's going to be a water tube or a fire tube, we're seeing issues here. All right, here this is cracked. This is from high temperature. You know, you get a scale buildup, you don't get the heat transfer to occur to get into the water side of things, and you start fatiguing the metals out there. So
must be that Canadian water.
That's right.
There's a hint there.
What's that?
There's a hint there that that's Canada.
Yeah. But I left it in there. So the good guys up there too.
That's right.
All right, but and a lot of people think, well, all right, yeah, those boilers need it. Cast iron, don't even worry about it. All right, we don't need to worry about it because in that cast iron boiler, it's got that big cavity on the inside, and a lot of the water, a lot of the dirt and stuff like that's going to settle out. Not anymore. Cast iron designs are changing. I want to show you this. I saw this out there. All right, this is a cutaway of a 5-year-old cast iron boiler of the section. All right, this, when it was brand new, was empty. This is a water passage. This is the fire side. All right, right here at the top of the heat exchanger of the chamber. All right, and this is all sediment clogged up in there. Okay, and what eventually happened, they cut this section out because right on the bottom side there was a crack that went in this direction. All right, now you would think, oh, it's going to happen on a seam. It's not a seam, it's where the casting is. All right, so it's not a seam, but it was a perpendicular to here crack in this heat exchanger, and it was less than 5 years old because it just got plugged up solid. All right, so you need to also consider water quality when it comes to your cast iron brothers. Okay. The older cast iron boilers, all right, I talked to my buddies at Will McLean. They sent over some pictures of some older stuff out there. I mean, look at the size of the holes there, all right? And also you start taking a look at the bottom side of these. You know, you had massive areas where sediment would fall out. We called them mud drums or mud legs, on purpose. We called it that because that's where all the crap settled out into. That's gone. We don't do that anymore. We have these, the passages are changing and the passes and the water flows and things like that. We also have to be considerate of the cast iron boilers. So, and I found this chart too. I thought this was pretty interesting as we saw forming scale in our systems. All right. And as the water temperature goes up, the percentage of scale formation is going to exponentially increase. Now, yes, maybe we don't have to consider it when we've got our ModCon boiler running at that 140, 150 range, all right, very low numbers. But once we start banging them out at 180 degrees, 10%, it's going to start forming more scale at a higher rate. So just more things to pay attention to. So this is where we introduced, we brought this out about 2 years ago, where we took the same technology of the 4900 air separator and turned it into a dirt separator. As in, you've got the collision media, you've got the pull rings in there, and you've got the large cavity where the dirt's going to come out of solution. All right, and then instead of having an automatic vent type of mechanism, it's a manual vent, but it's also got a magnetic ring around the outside to collect any magnetite, which is going to be your rust that you have in the system. So whenever you have these dissimilar metals and you've got cast iron or you got iron pipe in a system, and cast iron circulators, we're going to have rust. We're going to have rust in our system, and we want to make sure that we take care of it. And it doesn't have to be done chemically. We can do it with the magnetic dirt separator here. So using that same idea. All right. Now, I knew this chart was here. So here, guys, if everybody's curious, here's the CVs of the 4900 dirt separator. It's the same CV as the air separator. Obviously, it looks almost identical to each other, right? You take a look at the magnetic separator, it's the reverse of the air separator. All right, so design-wise is identical on the inside there. So when you take a look at a 1 inch or 1.25 inches, meaning 37 gallons a minute, you pump 37 gallons a minute through 1.25 inch pipe, you'll have 1 PSI pressure drop. Should you pump 37 gallons a minute through 1.25 inch pipe? No, 14, 15. All right, so as you can see, you got 37 gallons a minute going in there. I think you're over pumping going in there. So we're going to get the dirt and the magnetite coming out of solution. All right, the magnetic ring is going to hold it into place. All right, and again, doing the stainless steel and bronze, glycol, not a problem. All right, and Richard, wow, let me hit the button. What does the magnet chart mean?
That's 4.
That's 4 in a row, man. Wow. Okay, so 13,000 Gauss. All right, I want to talk about that for a second. So the ring on a magnetic dirt separator, it pops right off. Okay, so right over here, you'll see a little separation in the plastic, very flexible piece of plastic. You just got to slide it out of here. All right, and here you can see it pulled out. There's the ring. All right, very simple removal of it. Snaps back into place, and it spins on here. All right, doesn't have to set up in anywhere, but 13,000 Gauss is the magnetic strength. And what the heck is a Gauss? It's a magnetic flux density. All right, and yes, everybody just started thinking about Marty McFly for a second there, right? In the flux capacitor. Okay, what is Gauss? All right, Gauss is a magnetic strength, a field strength, not a magnet strength, a field strength. So just to give its relation, if you guys have ever seen any other magnetic dirt separators out there, like the Fernox TF1 has 9,000, the Caleffi Dirt Mag 2600, the 80 11,000. All right, I've been at plenty of trade shows where the Fernox rep, all right, and I know Patrick is one of them, and I'm sure he's done it at one of the trade shows that he's been to before, where he takes the magnet out of his unit and picks up a 007E circulator with that magnet. All right, that's 9,000. And I'm telling you that this little ring is 13,000. The reason for it is the way it's designed. Magnetic flux density means the magnetic lines, all right? Because we put the magnets in a circle, the density of the magnetic lines are very tight in the center side of it here compared to a bar magnet. You'll look at a bar magnet, all right, the lines get further apart, and it has to be a strong, I'm not picking up a circulator, obviously, with this thing here, but the Fernox TF1, you can, because it has to, it goes down the center, and it's got to be really strong to try to attract everything in here. So this is going to do a good job in that respect and get that, in getting the magnets, the magnetite out of there, all right? So that's what we're looking at for getting the dirt and the magnet stuff out of there. So we take a look at the inside of this thing. You see the pawl rings thrown in there, and as the water comes through, velocity drops, they fall out of solution. Any dirt, anything that you have floating in the water is going to settle down to the bottom. You close the valve, and here we show it comes with a hose bib if you wanted to screw on a hose bib, or you take this off and you just seal it with the cap itself. All right, so under normal operating procedures, you just leave that cap on there, okay, and then you open and close the valve. So as the dirt starts to fall, any magnetite, anything that's going to be stuck is going to stick to the magnet. All your regular dirt's going to fall down to the bottom. Make sure all your circulators are off. Make sure all your circs are off, nothing's running at the time, and then you can go ahead and come across and do a blowdown, all right, if you want to clean this out, and then close it back up again. All right, it's just going to be a quick little burst, boom. All right, we'll pull the magnet off first, though, actually, I'm sorry, yes.
Yeah,
Turn the pumps off,
very
make sure your
important
pumps
part
are
there.
off, pull the magnet off, let everything settle for a second, and then just go, all right, and you're going to get a small amount out, and you're done. All right, not a lot of work in order to get the dirt out of your system there and the magnetite. All right.
And that's
All right,
you know,
any
it's
questions?
interesting. That little magnet is the gaussiest magnet I've ever seen. I mean, I didn't know what a Gauss was. I had to go look it all up, man. I had to go look it up, and in terms of the Gauss, that's the gaussiest out there, and it's just a magnetic field. You know, so it's pretty cool. It's pretty cool. Some really good questions just came in. One, is there a concern in a dirty system that the pawl rings will get jammed up with junk? It's kind of their job. Again, what you have is a big open space in the piping, and it's inverted, right? You have a big open space in the piping. The pawl rings act as a collision medium, and as they hit the collision medium, and the velocity of that fluid has slowed down. Then the goal is for them to fall over time down into that bottom section. Again, we have not seen in a dirty system this thing get that gunked up. There's plenty of room for water to pass through here. What happens is, you know, chunks will collide, will collide with the three-dimensional solid surfaces and then fall to the bottom. That's where the, dirt and stuff, just from its weight, magnetic material due to the magnetic field created by the Gauss. Again, have we seen them get clogged up? No, we have not. In the years that we've been selling them, no, we have not seen that.
Here's another
it hasn't
question.
caused flow issues or anything.
Bob's just saying, based on the picture, it looks like there's a lot of little tiny pawl rings in there, and they are. The size based that we use are based on the size barrel of the unit. As Dave was mentioning earlier, we get up into some commercial product, the pawl ring gets a good size. These are real small. These are like 3/8 of an inch, in metric, something like that.
This video representation here, these pawl rings are a little bit bigger than the actual ones that would be if this is an inch or inch and a quarter. So they're going to be the same size as the ones that you see here.
Yeah.
All right,
pull it back a little. There you go.
There you go.
There. Yep.
So this is a 1-inch size. All right, the 1-inch, inch and a quarter, the 3/4, the residential size is all going to have this same size pawl ring in there. It's only when we start getting into the 2-inch and above do the pawl rings start to change in size. So the picture here, this is just a computer generated picture, obviously. That's if they did them this small, it'd be a little, just blur, so to speak.
And Dwight Eisenhower, Mr. President, thank you for joining us, sir. Best location.
So that's the first time he's heard that too, right?
Yeah,
First
I know.
time.
It really remarkably perceptive of me to come up with that on my own right here. When no one else has ever said that, right? Dwight, or should I call you Ike? I don't know. General, sir. The best location for the dirt separator on the return going back to the boiler. You want to use it to protect the boiler, especially for a mod con, but also for a cast iron boiler. So it'd be on the return side.
I'll bring up some. We do this on the commercial product and make it a little easier, but you could pull off that 1/2-inch blowdown valve and build yourself a little wand, because people were asking questions about the pawl rings actually getting completely stopped up. Of course, if you got that problem, you got lots of problems with your system if it's that bad. But you could actually put a wand in there and kind of blow the pawl rings out with water with a little wand. And as mentioned in the commercial product, we actually make the valve bigger, and so you could get a hose up there and clean out the pawl rings as well. But I suppose it could be done. I've not personally done it.
I think at that point you've probably reached the end life of your boiler if it got that clogged up over that length of time.
Yeah.
And you were introducing a lot of water, a lot of dirt into your system, and everything was getting stirred up. Yeah. Yep. Now, the last thing I want to bring up real fast is about ECM circulators. All right, and this conversation happens all the time, and I've been to a lot of trade shows, and I've been to a lot of counter days and things like that. When I've been talking about our ECM circulators, like the 007E, the 15E, the 18E, well, if you're going to put an ECM circulator into your hydronic system, you must put in a magnetic dirt separator in there, because the ECM circulator has a magnet in there. Yes, it does. It is totally made with a magnet. Okay, so when we take a look at that cartridge on the inside, all right, this is a magnet. I have nothing metal on my desk. Oh, yes, I do. Here we go. All right, so I do have some metal on my desk. All right, so we've got a magnet built into here. So all of a sudden people are saying, well, I got a dead circulator and I want to put in an ECM, but I can't. Or if I do, I must put one of these things in there, all right, in order to save the circulator. Now, do you think your customer really wants a magnetic dirt separator installed on a dead circulator when it was 5 degrees outside and I got to get the heat back on? Are you going to kill the system? No. All right. Now, with that being said, do you have to put in a mag dirt separator? Water quality could be an issue. Still consider it. I still like to see it on any system nowadays. All right. It becomes more and more important. However, with that being said, we do know not all what we have built into our ECM circuits, which we'll talk about in a lot more detail, is we have this barrier. It's not a filter. Okay, it's not going to filter any black iron oxide, any rust out of the system itself. It is a barrier that prevents any of the rust from getting to the magnet itself. Again, wet rotor circulators, we're not going to have water flowing in and out of this cartridge. What we're preventing is any rust from getting to this magnet side of things here. So that barrier prevents any of that rust, and it's almost like the magnet's not there, and the water, the magnetite stays in solution and sends on back out through the system itself. All right, and hopefully will settle out someplace else in the system itself. That is only true of our circs. All right, so that statement where you have to put a magnetic separator in with an ECM circulator will depend upon which brand circulator you're putting in. Okay, so we have that built in. As far as I know, we're the only ones out there that have this bio barrier built into the circulator. It's not a filter. I want to be very, 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 very clear about that. It is not a filter that you have to take the circulator apart and clean it on a regular basis. No. It doesn't get clogged up. Okay, it's just the initial water that flows through, and then that is it. Keeps going on from there.
Yeah, you don't have a constant exchange of water, constant flow of water, so it does not do a filtering job. What it does, it makes the magnetic crapola in the water essentially invisible to the magnets on the other side of the barrier. It's it's brass, so it's non-magnetic. It's like it's the cloak of invisibility. All right, it's the cloak of invisibility for you Harry Potter freaks out there, man. It's all right. Okay.
And what I mean by all fluid is about a tablespoon and a half.
Yeah,
is what floods the cartridge. It's a tablespoon and a half is what flows through that that barrier there. All right, so if you look at it, it's basically brass mesh that's just crushed down. It almost looks like an oil nozzle. All right, that the water flows through, and then that's it. Okay, and you're done. So, and then the other thing that we have built into our ECM circulators is that sure start function. If you haven't heard about it yet, sure start is that locked rotor. It's seized up. You guys all have experienced seized circulators in the past, right? Had you fix a seized circulator? Well, one, if you knew you had a seized circulator, you went downstairs to the basement, the circulator was calling for heat, but it's not flowing anything. And the circulator is like 300,000 degrees. All right, you can see that green paint starting to turn a little brown. What's the next thing you do, people? All right, I want to, and it's not in the instructions, but I know what you do and I want you to do it. All right, if you know you've got a seized circulator not pumping water and calling for heat, what's the one thing I want you to do? That's right, Brian. You whack it.
Whack it.
You just, whatever tool you have in your hand, all right, whether it's a flashlight, a screwdriver, a wrench, a channel locks, whatever you got, you give it a couple of hits to get it going. All right, rubber mallet, you're being nice, Ted. How many guys are walking downstairs in the basement with a rubber mallet? Okay. So we have this sure start. We basically have the hammer built into the circulator. So if it is seized up, it senses that the impeller's not spinning, it will stop and shake it back and forth really fast and then go up to 5,000 RPM to try to break it free. Okay, so that's what's going to happen with that circulator. So if it does get seized up, if the water's that dirty, it's going to automatically correct itself. It's not something that you can do. It's what's automatically built into the circulator. So you can't make our ECM circulator go into the sure start mode. You do that on your own, okay? And this also helps you get the air not out of your system, out of the circulator. All right, so if this circulator has air stuck in it, it's going to try to move the air out of the circulator itself. And I bring this up because I was actually having a conversation with some of the people back at the factory in quality control, and we've gotten a handful of our ECM circulators sent back. Not a lot. And because there's electronics built into them, we plug them all in. We want to find out what's going on because in our world, it's a new product. We've had ECM circulators now out for, since I started, 8 years, 9 years. All right. In the life of Taco, that's a very short amount of time. We're 100 years old, 101 years old. Okay. So we're checking out every circulator that comes back, and we have found 30% of them ran once. It ran once because it went into the sure start air free mode. All right, and the light was flashing like crazy, and it was making a little bit of noise. It was trying to get the air out of the impeller, out of the casing itself, and there's nothing wrong with it. It might take it a couple of minutes to get it out there, but let it keep going. All right, so that's built into our ECM circulators if your water's that dirty in there. If you start seeing sure start happening quite often in your systems, then you're starting to look into, hey, I've got an air issue and a dirt issue. All right, I might need to put more enhanced air and dirt separators into our systems. All right, if your circulator is getting seized up quite often.
Whew. That was something else.
That was a lot of stuff. I ran a little over, but I think we started a little bit later too, so that's okay.
Oh, that was very well done, and I love that Bruce Campbell picture. That's beautiful. That's absolutely beautiful.
He's got one big head on him.
Out of Winter Essentials. Yes.
Well, he not just the big head. Look at that chin, man. That's a chin and a half.
Yeah.
I mean, that is Hollywood's greatest chin right there. I got to tell you, Mr. Campbell. All right.
Kirk Douglas.
Well, but Kirk's dead. So, Patrick S calls us the Army of Darkness. Thank you. I think.
Whoa.
I guess that's a good thing. Hey, before everybody goes running away here, hey, don't be running off on us, because we have some stuff to give away here, which we're going to do in just a couple seconds. President Eisenhower asked about, does Taco make a combination air remover and dirt separator? And the answer is residentially, no. Our commercial products, yes. But for the residential products, no, we have our 4900 air separator and then the companion magnetic dirt separator as a separate item. Simply because you want your air separator where the water's the hottest, which is on the supply, and you would really like to have your magnetic dirt separator on the return before going back to the boiler to protect the boiler. Having them together is convenient, all right, and it sounds cool, like it would be really, really neat. However, keeping them separate is probably more, not probably, it is more effective in terms of hydronics and in terms of control and in terms of protection. And Jim Prisby, our central regional commercial sales manager, says we make all kinds of combination air remover and dirt separator on the commercial side. How big do you need it? Okay, on the commercial end, we make them wicked big. How big do we make them, Jim? I mean, that's we're getting up to 36
24
inches.
or 36 or big enough.
36 inches. So there, yeah, if you need something bigger than that, well, we can't help you, I guess. All right. Would a combination one be better for chilled water? Now, there's a good question, guys. Chilled water, would that make some sense?
Only if you need hydraulic separation. Otherwise, John, you already answered the question. Air separator goes on supply, dirt and magnetic dirt separators go on return. So there's not always need to be at the same location.
Yep. Very good. All righty. And guys, this is kind of the open forum part. So any questions about today's presentation that you would like to ask, or any questions in general, please ask them. Now, what I want to do though is we're giving away 5 gift packages plus 1 grand prize package for tonight, and we've kind of randomized your names while you were doing the presentation. We kind of randomized all the people who are in attendance, and we picked out some winners. So Dave, can you quickly go over what the t-shirt and mask proposition for 5 lucky winners? What's the t-shirt like?
All right, so I've got some t-shirts made up, specially made, some Takeaway After Dark t-shirts. I don't have them here yet at the house, but they are on their way, where we're going to see, very similar to the golf shirts that you see the 3 of us wearing. We're going to have a Takeaway After Dark on the chest here. We're also going to have a nice Takeaway After Dark on the back, and you'll see the Takeo logo is going to be on the sleeve. So those of you that win tonight, I haven't been involved in that, so that's John and Rick has been in charge of that. So if you win, type in your shirt size. I have everybody's mailing address. All right, so when you registered, I've got your mailing address, so I'm going to look you up, and we also have some Takeo masks out there too. So make sure you type that in there. As for the grand prize for tonight, you'll also get a t-shirt, but I also have some. Let's see what else I got. I got Takeaway After Dark coffee mugs. So obviously the ones that you leave on every job site and you have to go back for, sitting on top of the water heater, right?
And real quick, here's the mask, just so you know. All right, they'll take a logo right on the corner there.
All right. Let's see here. You'll also, I got anybody into stickers, doing sticker swaps. Hey, if anybody's a sticker swap guy, look me up on Instagram, Takeo Training. Give me your address, like me, follow me there, and I got some stickers I'll send out to you. And I'd like to get yours too. So if you've got some stickers out there, send them on over. I've got my board that's working, and I also have the toolbox to Takeo that's going to get them on there. So send them on, and I'll send you anything that you want to. If anybody's looking for any, find me up on Instagram. And the other part of the grand prize is a small Bluetooth job site speaker that we call the box amp. All right, so instead of having the earbuds in, you got a nice little Bluetooth speaker, cordless, rechargeable batteries. Let's see what else I got. Takeo hat.
Nice. He keeps grabbing, man. There's no end to that bucket.
Yeah, I got a couple of screwdrivers, the little screwdrivers that you can never find. So I got a couple of those, and koozies like this one here that I've been drinking out of tonight. So, and of course, a bottle opener, keychain, not a bottle opener, it's a keychain, right? Because we're not going to promote drinking at job sites. So got a bunch of stuff here just to say thanks for those of you that came and hang out with us tonight.
Very good. All right. Now, okay, let's go with our mask and t-shirt winners. Our mask and t-shirt winners are Thomas Alves. Thomas, for one of your brilliant questions, you are a hat and t-shirt winner. Stanley Hill, you are a hat and t-shirt winner, or t-shirt and mask winner. There we go. Let's get that right. James Tamblin, you are a mask and t-shirt winner. All right. Kevin McGowan, you are a mask and t-shirt winner. And Sean O'Keefe, you are a mask and t-shirt winner. So Thomas, Stanley, Sean, James, and Kevin, please type in your shirt sizes here if you would, and we will make sure you get your gift packages. We will get your gift packages out, your mask and your t-shirt. The mask is one size fits all. You got an abnormally large head, we can't help you. I'm sorry about that. And
Dave,
for the
go ahead. Go ahead.
Oh, and for the grand prize package with all that wicked cool stuff that Dave just mentioned to you, that's going to go to Bob Dressler. Bob Dressler.
Hey.
All right. So congrats you all. Congrats you all. Put your sizes in there, Bob. You as well, because there's going to be a T-shirt in there. But we have all of your information, and we'll get all that stuff out to you. So that's very cool. I'm really happy for you guys. I'm really glad you came, and I love the fact that we had such a good good turnout, and we had such a good time tonight. And
Thanks,
like I said, these things, when we did them over the summer, there were a couple we did about 2.5 hours worth, right? We were still yakking away at 9:30 at night. Okay. Just talking with each other, and we would still have anywhere from 50 to 100 people still on, which is really, really cool. So we appreciate that. We appreciate you being here. And one of the things we're here for you is to answer your questions. We can't get out there in the real world, unfortunately, but this is our way. This is our opportunity to interact with you guys and to answer your questions and to share time with you. So that's kind of where we're at, and that's where we'll go with the rest of this evening. Okay. Some nice comments. Thank you guys. Thomas, good question. Suggestion: register for all the events at once. You know, GoToWebinar has a function for that. Unfortunately, the functionality of GoToWebinar means that we can't send you any follow-up information until all the classes are done. What we do is we send you a follow-up email after the class is over with a link, with a certificate of your attendance for this one class, as well as a link to the recording of this class. This thing's being recorded and it's being archived. If we use the one registration function on GoToWebinar, all that goes away. So we waited out. We tried to make a decision. Is convenience versus guys calling us all the time saying, well, where's the recording? Where's everything else? It turned out to not be that convenient. So what we will do in the follow-up email, not only will you get get all that information, you also get a link to sign up for the next one. So we try to make it as easy as we can for you. It would be nice to be able to do that, but it comes at a cost. And what we decided was the cost wasn't worth it. Based on, we tried that for one session of a different program, and that's where we learned that it caused more problems. So Jerry asked how many we had. We peaked at 195 people out there. 195 out of 427 or 417 registered. So our turnout was a little less than 50%, but about 50% is normal.
Mm-hmm. Question says, did somebody already answer that one? Looking for friends and family, pricing for personal use, that's something you deal with your wholesaler and the local rep.
Right. So, yep. That's not something we get involved in.
We don't do pricing
right out of our hands.
Thank goodness.
I don't know how much any of this stuff costs whatsoever. I know what it does. Talk to the local reps out there. Yeah.
Yeah. Stanley Hill asked a good question. If you can't make the webinar, can you see it later? Yes. If you registered and were unable to attend, you'll also get a follow-up email with a link to the recording. You don't get the certificate, unfortunately, but you do get a link to watch the recording. In addition, these recordings are going to be archived on Taco's YouTube page and on Mechanical Hub's YouTube page. So they're out there. If you go to either one of our YouTube pages, you will find all of the all of the Taco After Darks, going back to season 1 last spring. So they're all out there. If you and that'll take you about a month to watch them all, but I think it's a month well spent, quite personally. But yeah, they're all archived on YouTube. They're all archived. There are links actually to them on our website, but either our YouTube page or Mechanical Hub's YouTube page, and you will get follow-up emails. If you register and don't attend, you'll get an email to say, hey, if you want to go watch it, here you go, and they'll also be linked online. So you've got
There's
all the
on the handouts, that reminds me of something. We were talking about pictures of different applications and stuff. Dave and I were talking earlier. Dave has the residential catalog as a takeaway or something that you guys can download right now. It's a PDF. And in the back of that catalog, there's a bunch of different sketches showing all kinds of different piping schemes and zone valves, circulators, all that stuff. So take a look at that. I think those will give you answers to some of those questions you had as far as location. So.
Yeah, very good. Yeah, on the handout section on your control panel, you can you can download our residential product catalog, as well as what we call a takeaways brochure, which is some math formulas and things like that to help you along when you're designing a system. So those are all there for you for your use. Taco rep for Southeast Wisconsin. Southeast Wisconsin. That's going to be, I believe that's going to be Mondale and Associates. If you're in the La Crosse area, that'll be Mondale and Associates out of Minneapolis for residential products, for wholesale products. Commercial products, I'm not sure if it's RM Cotton or if it's
well, Prisby's on here. He could tell us.
Oh, yeah, Prisby just said Southeast is fluid handling out of Milwaukee. Fluid handling out of Milwaukee for commercial products. Residential products would be Mondale and Associates. Okay, are we going to go over the takeaways sizing? Now that's we can do that at any time, really. I mean, it's what particular sizing part do you want to go over, Bob? Because we can go over that. We can go over that at any time. We can go over it now if you want to.
So some of the size, yeah. I'm assuming some of the sizing. Oh, go ahead, go.
One quick question about a rep for South Florida would be the Harry Warren Company. But Gustavo asked that. It's the Harry Warren Company. Oh, Bob asked one good question about the takeaway sheet. What is DTD? DTD stands for design temperature difference. When you're doing a heat loss, you have to know what your design temperature difference is. It's a multiplier that we use. And what the design temperature is, it's the difference between your desired indoor temperature. Let's use 70 degrees as a number. 70 degrees indoors minus your outdoor design temperature, your quote unquote coldest day of the year as recommended by ASHRAE. Let's say I used to live in Minneapolis. In Minneapolis, the outdoor design temperature was 15 below zero. So if we were in Minneapolis, our DTD would be 70 minus negative 15 for a spread of 85. So the design temperature difference, the multiplier that we would use would be 85 degrees, with the idea that if I had cold air coming in at 15 below, I would need enough BTUs to boost it up to 70. So that's kind of where what that number means and where it's come from. Your indoor to outdoor delta T, I guess, would be Stephen Bailey. I think that's what you're referring to. Yeah, the indoor to outdoor temperature difference. Okay, but when doing a heat loss calculation, it is a multiplier. So when you are calculating, let's say the heat loss of a window through a window, you want the length times the width or the area of the window. So multiply the area of the window times the U value of the window, the rate, its insulation rate, basically. At what rate does it transmit heat? So it's length times width times U value times design temperature difference, and that would give you the heat loss through the window assembly. So say a 3x5 window, that's 15 square feet. If it's a low E double pane wood or vinyl frame window, that is a 0.36 U value. So 15 times 0.36 times 85, okay, which is your design temperature difference. Well, then that'll give you the heat loss through the window, okay. And yeah, caution when doing this for the LD when they like it at 75. Yeah, you know, that's an interesting point. People get a little worried about that, but let's think about this for a minute. Think about this for a minute. Let's say I do a heat loss at 70 degrees, 70 to minus 15. That's 85-degree delta T, your design temperature difference. And let's say I do that math. And for this house, I come up with a heat loss under those conditions of 57,421 BTUs. When is the heat loss of that house 57,421 BTUs? When it's 15 below zero. That's the only time it's going to be 57,421 BTUs. The rest of the time, it's going to be less, okay? That's part one. Part two is I have to put a boiler in, right? I have to put a boiler in to deliver 57,421 BTUs. How likely are you to find a boiler that A, has a net rated output of 57,421 BTUs and not a drop more, okay? Or are you going to pick the brand you like, size up that covers it? Let's say the brand you like, size up that covers it is 75,000 BTUs. It's a 75,000 BTU output boiler. And you put that boiler onto the system that needs 57,421 BTUs. What you have now is 18,000 BTUs sitting around looking for something to do, okay? Looking for something to do. As long as you have that horsepower in the boiler, okay? As long as you have that horsepower in the boiler, if somebody wants to set it to 75 when it's 15 below, they're gonna get there. Okay, they're going to get there. At that point, it's just a matter of BTUs, and we have them available. So yeah, I get where you're going with that, but there's so much fudge built into even that 57,421 BTUs that we calculated probably has a boatload of fudge built in anyway. To the point that it's little wonder that we're not all diabetic. That's how much fudge. I love that joke. I've been telling that joke for 20 years. I may be the only one who thinks it's funny, but I think it's funny. So
no, I catch it. It's funny watching you tell that joke in a class, and when people are hanging on every word, all right, and they're getting the scientific part down, and you say that, some of them are like, wait, what? I heard that. I heard fudge. Some of them are just writing still and didn't really hear it. So I pay attention to the class when you and I are together, so it's quite funny. So,
yeah, there you go.
But also that we will, you know, the takeaways handbook is really a addition to our what we call our spring and fall class. So in the spring, when John and I and when the three of us start up again in the spring for our 10-week session, that will work into that conjunction. So if you really want to learn what that book is going to be used for, is really starting with the spring session. The winter session here was just different topics that we wanted to cover over and still have fun with. So that's the beauty of the winter, is that you don't have to go to week 1 in order to go to week 2. All right, in the spring session and the fall session, it's a good idea. Again, you don't have to, and if you really don't want to wait till the spring, again, jump back to YouTube pages and take a look there. And I'm going to change subject really quick. So for those of you that are looking for reps out there, I want to show you guys a nice little easy device to use. It's called we have a Takeo app. All right, let me see if I get the focus on there. And if you click on the Takeo app, all right, it will ask you, you could find where your rep is at the bottom, find a sales rep. So you see it down at the bottom here on this side, find a sales rep, type in your zip code. It's going to tell you and give you all the information of those guys. So the app is a really powerful tool. We've got on the commercial side, pump selection tool. We've got a bunch of our how-to videos, the literature that you want to run into, factory training classes. Obviously, you click on it, you're not going to get to us. The app for the 0018E, which we're going to talk about in a couple of weeks, the DHW sizing. So very, very powerful app that you've got here, and take a look at. So Robert, give me, I will take a note and I will email it to you. I have your email address, Robert. I know you're looking for the handouts because you're on your phone. So I will send that to you.
Yeah, again, for the rest, remember on your control panel, look at your control panel on your computer screen. There should be a section marked handouts, and just click on that stuff and you'll download them. All right, you'll have the residential catalog as well as the takeaways brochure.
Hey, Johnny. Johnny, this is
Yeah.
John.
I
Hey,
hear a
John.
voice.
I heard another voice.
Hey,
Woke me up.
great show tonight, man. I got a question. It's a really important one. I love the new matching shirts. But is that the end of theme night for you Utes?
Oh gosh, no. No. I'm guessing by the spring season, the t-shirts will make a little bit of a comeback. We may, now that we've shown these, we'll see, you know, maybe we'll have wardrobe changes during the presentation. Who knows? You know, I'll step
Giving
off
too much
camera,
information.
all right, to change my shirt because that's way more hair than anybody needs to see. All right. But yeah, we'll we'll be definitely doing that. Because I got a bunch of brand new t-shirts too, just for the next season. So I got some good ones.
I love it.
Yeah, man, I got some real good ones. And it's every time, and I bought so many that now my Instagram feed and my Facebook feed is filled with, you know, novelty t-shirt ads.
Hey, you started a
Abundance.
I'm
Where
gonna
do you
have to
put 'em
buy a
all?
new dresser too to put all these things in too.
Yeah, where do you put them?
They're stacked all over the place, man.
Time to get rid of some old stuff then.
Yeah, I got to weed through that. You know, someone with whom I live said maybe you should get rid of some of your golf clubs, and that didn't go very far.
How dare she?
Just doesn't know. Just doesn't know. I got a new wedge too, by the way.
Oh boy.
Yeah. Oh,
So,
there you go, baby, right there.
oh, Wilson.
It doesn't even see it.
Yeah.
It doesn't even. It's forged. It doesn't even have the plastic off it yet, man.
Still has the sticker on it. Wow.
It's a virgin wedge.
Hmm.
There you go. All righty. Yep. Okay. But Bob, you found the app. That's good. There's again a lot of cool stuff on that thing. The domestic hot water research sizer is pretty helpful. Give you some good ideas there. A lot of good stuff. A lot of good stuff. So Kelvin asked about the 10-week session. Did we talk about that? The spring session?
Quickly, I talked about it, but we haven't set the dates for that just yet. So we will soon enough. We will get the,
Right. But we'll probably start that probably April. I would say April. This session goes to March 17th. So after that, yeah, we'll probably start early April and, you know, go for 10 weeks. Can you go over the pressure reducing valve, the take-o pressure
we didn't talk
reducing
about
valve?
next week.
Oh, wait, what are we going to do next week?
Next week is pump curve essentials.
Oh, that's my week.
You're
That's
on.
my week. I better get ready.
Yes. Yeah. So next week, for those of you that are still hanging out, is now everything you wanted to know about a performance curve, but was afraid to ask.
Mhm.
So we're going to
Or never
really
thought to
analyze.
ask, or really didn't want to ask.
Yeah. So we're going to really analyze the importance of looking at these performance curves of circulators and stuff. So that is next week's class. So same bat time, same bat channel.
That's right. With these bat crazy guys, man. Yeah, that's going to be fun. We're going to talk about, and curves matter, you know. Interesting. Dave and I did a session for some folks in the Midwest who were not new folks who really didn't quite understand hydronics to the extent that you know that this group here does. You know, and some very interesting questions, and it really does get you grounded, because if you've been around stuff like this, you start to assume certain levels of knowledge, but you really you don't, you know, not a lot of folks do that. So we're getting kind of to the basics. One of the things that even experienced people don't quite understand is, what is a pump curve, where does it come from, and why the hell do I care about it? I just want to put a pump in and make the water go round and round. I want to overthink this. Well, there's a certain value to not overthinking it, but there's a better value to thinking it. All right. I can remember going on webinars and as a guest, and some people saying, well, this thing takes the thinking out of it. It does the thinking for you. And you want to reach through the screen and slap that guy, because you don't want to take the thinking out of it. If anything, all the stuff we talked about tonight and the questions you guys asked weren't about taking the thinking out of it. It was more about putting the thinking back into it. You know, and that's one of those things that always makes you wonder. I mean, when we're talking about circulators, we're talking about anything in hydronics. we're the professionals, right? The people in this on this webinar, we're the professionals. We do this for money. We do this for a living, right? This is our job, but beyond that, it is our profession. Okay, it's our profession. We need to know this stuff. This is the stuff that's important. We need to put the thinking into it. All right, we need to know the details. I don't think anybody would go to a doctor who said, yeah, you know what? I'm gonna ballpark it here. You know, I'm gonna use rules of thumb, and I'm thinking maybe it's the appendix. Let's just cut it out and see. That's not the doctor you want to go to, okay? So let's hold ourselves to that same standard. So that's the important stuff that we're going to be talking about. And when it comes to understanding pump performance curves, some are flatter, some are steeper. There's a reason why that you have flat curves and steep curves, and they have different applications. And if you put a flat curve pump in when you need a steep curve pump, there's a problem. If you use a steep curve pump where you really need a flat curve pump, there's a problem. And the funny thing is, the problem might not be that the system doesn't work in your cold. You may put in the wrong pump. It works in that nobody's freezing to death, but you've created 3 or 4 or 5 other problems that are going to cost the customer money today, tomorrow, and every day that system runs, and cost them even more money when the problem causes something to break. But by golly, until that day comes, they're not going to be cold, pal. So you've got to understand, just because it doesn't look like there's a problem doesn't mean there isn't a problem. And that's looking beyond the obvious. That's understanding dynamics and curves and stuff. That's what we're going to talk about next week. And do you think I get excited about this stuff? I do. Boy, a hush fell over the newsroom. What happened?
Well,
Sorry,
I mean,
was typing.
James is wanting to know if we're going to cover net positive suction head, and not in this class.
Suction head. You know, in residential applications, the net positive suction head never really comes into play. On commercial applications, it's monumentally important. Most of the problems with commercial pumps start with not understanding net positive suction head. On the residential end, it really doesn't come into play unless it's an open system using an outdoor wood boiler. Then you might see a net positive suction head problem rear its ugly head. So that's kind of or a steam boiler where you're trying to zone below the condensate line. Yeah, that's another instance where you might have that. Okay, so I think that those are the instances where you might have a net positive suction head problem inside that in that kind of a house in a residential application. Commercially, it's a much bigger deal.
One thing that Thompson pointed out that I never really got until it finally slapped me in the head is on wet rotor circulators, talking closed loop wet rotor circulators. The emphasis is more on worrying about the water inside that rotor assembly. It's not, most people that understand net positive suction head understand that we might cavitate, right? And the cavitation normally takes place in the volute of the circulator, you know, from the low pressure side to the high pressure side on the tip of the impeller, et cetera, et cetera. Those are the things when people start thinking about how much pressure needs to be on the suction side of that circulator. So in other words, what we're worried about with wet rotors is the issue of boiling the water inside the can. And that can be taken care of just having pressure on the suction side of the pump. Normally, anything that we're doing in the realm of 10, 12, 15 PSI, you're not going to have a problem with either of those things. When we have a problem, it's when we start getting to open systems or we get into some different types of applications, drain back systems that don't have enough pressure on the pump and things. So again, usually in residential applications, not something to worry about. And I say that because some of our literature actually misleads you. If I showed you a piece of literature and it said the net positive suction head needed to be 18 PSI, what would you think?
I'm sorry, I missed the question.
I said, if I had a piece of literature and I showed it to you, and that manufacturer said the net positive suction head required needed to be 18 psi, what would you think?
I would think it needed to be 18 psi.
Negative. It's always, you know, that's why it shouldn't say it that way. It should just say, how much pressure do we need on the suction side of the pump? Because people will misunderstand that, you know. It's just not that. Everybody, right? Everybody that normally looks at something, if it says 18 psi on it, they're going to think, wow, I got to figure out how I can get 18 psi on that pump. But again, you know, it's one of those chart things that's easier to show you if we pulled up a chart. And
There you go.
yeah, in fact, I don't know. You guys keep talking. I'll see if I can find it real quick, and we could put that to bed. So.
Okay, very good. Did Jeff Lippert asked a question, which is why I got up. I'm playing with the Taco Comfort app on the DHWR sizing. It asks for piping layout with options being crossover valve or crossover circ. What does that mean? There are two choices before that, and it has to do with, is there a recirc line, yes or no? If there's no installed recirc line, okay, meaning the house, it's an existing house and there's no recirc line installed, then it's going to default to either a crossover valve or crossover circ. And this is a crossover valve. This is the Hotlink crossover valve. And what this does is this goes under the sink, okay, and you make a couple of connections. These go up to the faucet. Your hot water, let's see, your hot water is gonna be on this side. Your hot water angle stop, you get a hose and it'll connect to this side, and this side connects to the cold water angle stop. Basically what you're doing here is you're using the cold water line as a return line for your domestic hot water recirculation. Okay, now what's the first thing you're going to freak out about, man, once I tell you, oh yeah, the cold water line is going to be your return line for your hot water? Oh my God, no, we're not going to have hot water in the cold water line. Glorioski, who would do such a thing? Well, certainly not us. That's why this is a valve and not a T, okay? This is a valve. If you were to unscrew this part right here, you would see the reason it can be done. This is a cartridge, but right here we have a thermal sensor disc. Say it with me, thermal sensor disc. This thermal sensor disc, once the hot water gets here, and in a domestic hot water recirculation, think about it, hot water generally travels in slugs, right? Once that slug of hot water gets here, this disc will snap closed. So what happens is, all right, the hot water's coming this way, hot water's coming this way. No, the hot water's coming this way. There we go. Coming this way, it hits the disc closes. Now I've closed off the return line. So if I get any hot water in the cold water line, it's maybe about this much that will be gone by the time, you turn on a cold water spigot, it'll be gone by the time your hands get under the flow of water. All right. So this is the thing that makes it work. It uses that cold water return line, that cold water feed as the hot water recirc return, but it doesn't run all the time, right? The circulator itself is running based on various control strategies, whether it's a timer or a smart plug, all right, that we have. So, the pump at most is going to run 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off, for maybe a couple hours, right, depending upon how you set it up. So yeah, I hope that answers your question.
Patrick ran into a situation where apparently there was shipping foam or one of those foam little worms shoved up inside the check valve, and apparently it doesn't work real good when that happens. So
that would be a problem. Yes, that's one of those things they don't put in the troubleshooting guide.
Yeah.
Check for packing material. It's not a wax cartridge. No, Bob, it's not a wax cartridge. We made very sure not to make that mistake.
Very
okay, cool. We said we want this. In fact, these are being sold separately and people are using these to replace the wax cartridge types instead of putting in another wax cartridge type, because they don't want to go back in 12 to 18 months and replace it with another wax cartridge type. So that's a huge market for these guys right here. But yeah, thermal sensor disc, Hand tight. It's field serviceable too if you ever need to. But hand tight is the important part here. You do not need a 3-foot wrench and a 4-foot cheater bar to snug this sucker up. Hand tight works just fine. Okay.
Hey, I found that chart if you want to look at it.
Okay, real quick, just the crossover circulator is another product that we have that we use. It's called the Taco Genie, Jeff, that we use with tankless type water heaters we only want it to run when there's an imminent call for domestic hot water. So if there's no return line, there's a circulator that can actually be mounted under the sink with a sensor, a temperature sensor that'll shut the circulator off when the hot water arrives. So it's another way of doing it. You have to be able to get to power that circulator underneath the sink. There's a challenge there, but that's the other alternative, okay? So that explains that part. If you had selected, yes, there is a return line, a recirc line, you wouldn't get either the crossover valve or crossover circ options. And Mr. Mayo had a lot to do with that, so kudos to Rick.
Hey, I'll take it when it comes.
Hell yeah.
So share screen.
Please do.
Kaboom. It's not letting me.
Oh, I gotta hang on.
You gotta make, yeah, Dave's gotta make you the presenter.
There we go. Show my screen. And now can you see that?
Yes.
Take that. All right, so let's pull this over a little bit. As long as you can see it, I'm going to shrink this back. So for instance, let's use that example. By the way, that 18 PSI is a typo, unfortunately. But even if it were 18 PSI, let's think about that. Now, Dave was talking about absolute pressure before when we were looking at some of that information he was showing you on solubility. But understand, absolute pressure is not 0 PSI gauge. 0 PSI gauge is actually 14.7, okay? So when we're talking about a manufacturer like Taco or any brand that talks about net positive suction head required, they're always talking about an absolute, based on absolute. So even if that was correct, let me make sure you get this. This line here is at 0 PSI on a gauge that you have next to the pump, okay? So if we were at 18 PSI absolute, it would only be about 3.5, 3.25 PSI on your gauge. Does that make sense? You could see over here where it is in feet of head, okay? Here's where it is in PSI A absolute. And once we get up here, then we get into PSI G. There's 3 pounds, 4 pounds, 5 pounds, etc. So understand that, again, with these wet rotor closed loop jobs, you hardly ever even have to consider it. But it's nice to have an understanding. I drew this up just to get my own arms around this whole thing with absolute pressure versus gauge pressure. And hopefully that helps. Boom.
Beauty.
Excellent.
All righty. Very good. Very good. This is good stuff, guys. This has been a lot of fun. Lots and lots of fun. All right. Any more questions that you folks have? Because we could do this all night. Messenbrink's already given up, man.
Wow.
He's turned in. Wow. He went to bed.
There was a comment that came in before from Omer. I believe it was. Yes, he was looking at. He wanted me to talk about the 3450.
Okay, go do that real quick.
Yeah. So obviously, I had a picture of it on the boiler trim kit, on the premium trim kit that we had. Where this is a standard item on that trim kit. We've got the trim kits in 3 different sizes, or 3 different configurations, so to speak, and 2 different sizes, 1 inch, 1.25 inches. And the premium comes with the 3450. So this is our combination PRV and backflow preventer in one device that fits in the same space that you've had for, say, a standard PRV installed. So I know here on the East Coast, I've got a lot of older systems out there that only had a PRV installed. And now if you end up touching it, it's requiring a backflow preventer. So rather than having to cut the pipe, you can go ahead and drop it in and you'll get your backflow preventer, which is this component of the brass down here, and then your PRV is on this side. All right, so your water flow is coming in this way over here. It comes down, hits our backflow preventer, comes across to the PRV, to your pressure that you want, and then back out to the system itself. We've got a check valve built in. All right, so we can at least make, and this is also a serviceable device. All right, which means we can take it apart and clean it if need be. So there is a tool that you can get, or channel locks, in order to take it apart. So the cartridge side here, you can unscrew and service it and clean it if need be. So it does have a filter on the inside, a screen to clean it out, and or replace the cartridge so you can leave the brass in place and drop this back into place. And we also have on the backflow side, so this part here, you'll see this star pattern where I like to use actually an adjustable wrench to pull this off, and you can pull the cap off on here and you can get to the backflow preventer. You can pull this out, get a pair of channel locks in there, get needle nose pliers, pull that out, clean the screen that's on there and reassemble, or get replacement parts if needed. Sweat, thread, and press on here. It comes defaulted to 12 PSI. It is adjustable up to 50 PSI. On the PRV side of things, you have an indicator so you can kind of see what your setting is going to be. I'm sorry, trying to work at the glare in there, but there's a little dot in here that's going to move up and down. The way to adjust this, all right, like I said, it comes already set for 12 PSI, you're good to go. But if you want to change that pressure, what you do is you take the black part on the top here and loosen it. So turn that counterclockwise. That's your locking ring. In order to change the pressure, you then grab the green knob. And if you can see the green dot down there, you're going to see that moving as I turn that green knob, and you're going to get an indication of where my pressure is.
Yeah.
And then once you're done, lock down the black knob. In order to do your fill, this is the sweet part here. All right, this is the official training on how to use the PRV. All right, the 3450. You take your index finger, all right, put it next to the device and lower your finger. Hit the button and release. Once you hit that button, that is your fast fill. You don't have to hold it. You just press it once. That's your fast fill, and it's going to fill your system up until it gets to the pressure that you have it set here. Once it hits that pressure, pop, the button comes up and releases.
Yeah.
As we all have done before with PRVs, all right, when you're purging out a system, you never want to be far away from this where your drain valve is. And if you are, it's like that.
Oh, the nightmares. They're coming.
The
Flash
your way, so you can take that jump to get there before the relief valve on the boiler pops. All right, so this is going to help not let that boiler pop and make a big old mess everywhere. So one thing to know about it, it does fill a little slower than what you may be used to, say with our standard 329s, but you're not going to make a big old mess everywhere. Okay, so very, very, and then of course it's got the atmospheric vent that you're going to have to bring down to the floor. This part here, all right, this black knob here, if you wanted to, you could put a pressure gauge on it, but I wouldn't. That is actually a relief. So if you have the system filled, okay, you shut your water supply off, all right, which you're going to have a valve over here on your water supply in. You got a check valve on the boiler side. But what I want you to do is, if you ever needed to take this apart, you got to get the pressure off of it. Otherwise, these threads are really hard to move. You just crack that right there. If you were to put a pressure gauge there, it's just going to tell you street pressure. It's not going to know what your boiler pressure is. And that's where that picture that Rick was showing, that I showed earlier, the one of the first pictures I showed, where it showed a pressure gauge where this fed into the system, you know, right by the expansion tank. That's your true pressure reading on the system. Yes, we use the convenience of the pressure gauge in the boiler, but if you really want to know what the fill pressure is, it's good to put it right by this thing here.
Very good. Priz made just if anybody wants to know anything more about net positive suction head, we have a great recorded webinar titled Centrifugal Pump Selections and NSPH. And that's on the TACO YouTube channel, Mechanical Training Systems video number 3. So make sure you check that out. That's pretty cool stuff. And Patrick S. asks, Is there anything better than peanut butter toast? I can think of 2 things, but I can't bring them up here. That's maybe all. Peanut butter toast. For all due respect to beer drinkers out there and to Benjamin Franklin, peanut butter toast is proof that God loves us and wants us to be happy.
That's
You could-
beer. That's
No, that's
beer.
peanut butter
No, I seen the
toast.
T-shirt. I seen it.
I said with all due respect, didn't I say with
Okay.
all due respect?
Oh,
It's a Ricky
okay.
Bobby line. I said with all due respect, right? With all due respect, peanut butter toast is proof that God loves us and wants to be happy. In fact, peanut butter may be what they meant by ambrosia.
Good band.
Yes, good band, but it may be the food of the gods. Peanut butter. You could put peanut butter on an old shoe and it would be delicious. That's all I'm saying.
You've been around the dogs too much.
He's been
And my wife's
vegetarian.
gonna get
too
me
long.
one of those Kong toys, you know, and fill it up with peanut butter and throw it at me. I'll be busy for hours, man.
Yeah. I think he's been vegetarian too long now.
That could be it too. Been vegetarian for
Year and a half.
16 months
Almost.
since
Thanksgiving.
Thanksgiving of 2019. So 14 months. 12 months? 14, 12, 14, about
It
15
was
to
12
16
weeks
months.
in November right now. Yeah.
Yeah, it's hard. I
better
lose
do
track
math
of
for you.
time with this, lockdown, quarantine, no going anywhere stuff. I mean, I sit in my office all day. I look at the same 4 walls. I'm lucky I know what time it is, forget what day it is. That's just the way it is. Do I lead a sheltered life? I don't think I lead a sheltered life. I lead a solitary life right now. I miss my friends. I miss people. The dogs and I have wonderful conversations during the day. I got to tell you, I've shared things with those dogs that if they could talk, they could blackmail the living crap out of me. I'll tell you what. And a toasted English muffin. Oh yes, peanut butter and a toasted English muffin. I like where you're going with this.
Well,
I think we might have a little after webinar snack coming up here.
yeah,
man.
dinner
Crunchy
for
peanut
me.
butter. Crunchy peanut butter.
Yeah.
Sesame bagel. Throw it in the toaster oven for about 3 minutes.
So it drips.
Ooh.
Peanut butter on there, so it's starting to.
Oh.
And you want to sweeten it up,
Gotta
put a
be
little
good
honey
Long
with it.
Island sesame
Look,
bagel though.
there you go. A little bit of honey. There you go.
Yeah.
A little bit of honey. The other thing is banana bread. Warm the banana bread up in a toaster oven, right?
Okay.
Homemade banana bread with walnuts. Warm that up in the toaster oven, then spread some peanut butter on that. It will change your life.
Forever.
Okay? You will be in the presence of greatness. I'm
It'll
telling you.
change your waistline as well.
Well, yeah, if that's all you eat forever and ever, Rick, yes. But if you have it as the occasional treat for a day well spent, it's not. If you just said, I'm going to sit here and every night, I'm going to eat an entire loaf of banana bread with peanut butter on it, yes, it will change your waistline.
Okay.
But have
Any
a
questions?
slice.
Questions?
Have a slice.
Throw us something.
Yeah,
Throw us
Jerry
something.
says, we've been quarantined way too long. What did I just tell you? Yes, what did I just tell you?
We still got a bunch of you out there. Still about 80 or so out there. I'm sure somebody's got a question, unless you just want to hear us banter for the next. We'll stay on if you guys are listening.
With
Yeah,
a short break.
That's
Yeah.
right. That's right. I may need to take a biological break in a moment here, but that's
Yeah.
all right.
That's
Hey,
why
let's.
I only had one beer right now. So
There you go. I didn't even have a drink with me tonight. I didn't have my Pellegrino.
So, John, is it that you don't eat anything with eyeballs, right?
Yeah, no meat.
Oh no, think about it. Nothing with eyeballs. What if something didn't have eyeballs? Would you eat it?
What do you mean?
Well, I don't know. Think about eyeballs.
If it was ever an animal, I won't eat it.
Okay.
Okay. I don't do fish. I don't do meat. I don't do chicken. those are the three biggies. Okay, I don't eat
Yeah.
worms. All right, I haven't eaten a worm since that night in in Tijuana, but we don't need to discuss that.
Oh,
Oh, there we go.
mezcal.
Yes,
Mezcal.
that was the last worm I think I ever had. But
Ooh.
no fish. No. That was just it was a decision. My son is a vegan. Actually, he's what we call a Shiite vegan, meaning he's a vegan terrorist kind of a kid. And we had Thanksgiving with him in 2019, and he made all the meal, and he made a totally vegan meal, and it was delicious, except for the tofu turkey. The tofu turkey sucked. You cannot dress that pig up. It was awful. All right, it was terrible, but everything else was pretty good. And we said, you know what? I turned 60 last year. I said, let's make this change and see how far we can take it. And so far, it's been great. It's been fine. You know what I love most about being a vegetarian is no matter what I make for dinner, the cleanup is nothing. It's easy because you don't have that animal fat on the pans or anything. Cleaning up your pots and pans is simple. Done in seconds. Don't have to leave anything to soak or any of that garbage. That's what I love most about it. Do I miss a good steak? No, I don't miss a good steak. You know what I do miss is hot dogs. A really good hot dog. When I smell a really good hot dog, I go, that's about it. A really good hot dog is what I miss. Steak, I wasn't a big steak eater anyway. If I had a steak, you put a steak in front of me, I'd make it all gone. Okay, I was all right. But fish, I love fish. But just get those things going away doesn't really bother me all that much. A good hot dog and the occasional buffalo wing are probably the things I miss most, but that's okay.
How about
That's
those Polish dogs at Costco?
Polish dogs are any good hot dog, any good dog,
Oh, that thing's foot long.
Yeah, baby, those are all right.
Garlic. You'll have garlic taste for, a
I'll
week.
tell you, the very best hot dogs I ever had were Pearl, brand name Pearl hot dogs. Those were fantastic. I mean, you just bit into them and there's just unidentified grease kind of gushing all over the place. They're like juicy and crispy at the same time. Fantastic. Absolutely fantastic.
Hey, Frisbee's trying to throw something out there. You guys, folks listening, this is for you. What is the most common hydronic call that you've got within the last couple of weeks because of this Arctic blast, or what's the real name for it? There's a fancy
Polar
name.
vortex.
Oh, polar vortex. Oh my God. I
Back
grew
when
up
I
in
was a
Alaska.
boy, they called it a cold snap.
Yeah, cold. Yeah.
Polar vortex, yes.
Anyway, so give us some feedback, folks. Tell us what you're seeing out there. What's your service calls, folks that are in the polar vortex and doing service calls.
And actually, that's a great comment there, Jim. You know what? Because that'll help us actually, as the manufacturer, as trainers too. At the same time, if we keep running into the same most common problems that occur out there, other than say dead stuff that died. But I do like that. I try to at least once a year. I take a few days and get out of the office and go hang out with a couple of local contractors just to run around job sites with them and see what they see on job sites. For us sitting back here in the desk, this is seminar land. What's seminar land? Oh, it's perfect. It's roses, it's daisies all the time.
And everybody pays their bill on time and they worry that it isn't high enough.
Right. So, and they give you an extra $100 just because you showed up at 8:01, and it wasn't 8:05 that day. So yes, we live in seminar land a lot of times, and I try to get out into the job sites as much as I can, and and the guys that I hang out with, friends of mine, and I'm gonna swing the wrenches with them too at the same time and help out as much as I can, just so I can see what you guys still continue to see out there. So I don't get out as much as I used to. My previous job, yeah, I was out on job sites quite often. Nowadays, and especially the last 13, 14 months, I've been behind this computer screen here. So just figured I'd throw it out to you guys. Let us know. If not, I guess that's okay too.
Yeah, not seeing much,
if
but
we want to call it an evening, that's fine by me.
Yep. From Patrick, overpumping has been a huge problem this week so far. Overpumping has not allowed the modulating boilers to fire at 100%, due to the lack of a system delta T, and they aren't keeping up. The wrong 3-speed pump is being set to speed 3. Well, glorioski Captain Obvious. Haven't we been talking about that for the past year? We have. Over pumping, my friends, is the bane of our existence. In most cases, over pumping does not create a no heat situation, but it does create problems later on, and it just basically puts a hard cap on what potential system-wide efficiency you could have. You're intentionally limiting the potential efficiency of a system by over pumping. All right. In the cases that Patrick's talking about, and apparently this is more than one Patrick, right? The system delta T, because you're over pumping, meaning too many gallons per minute, we're not losing as much temperature to the structure. We're over pumping. The boiler cannot fire up to 100% because the system delta T is too narrow. So it doesn't fire up as high because it thinks it's firing too much, right? It thinks it's firing too much. So that's an over pumping problem that you look at it, you think, well, I'm going to ram the hell out of that fluid and really make it go, but you're over pumping and the boiler's not doing what it's supposed to do. Most of the heating season, you'll probably get away with it. You'll probably heat the house, but when it gets this cold, that's when you put that limit on there in terms of output, and not to mention efficiency. Over pumping is the bane of our existence. It is a bigger problem than anybody wants to admit. And one of the benefits that ECM circulators has brought to us is that now we can peer into these systems and we have a greater understanding of over pumping, because now we don't have to. All right, we don't have to. 3-speed pumps, man, 3-speed pumps, I love them. They're terrific. They still have a place. But unfortunately, it's replaced thinking. All right, I got 3 speeds, turn it on high, let's get the hell out of here. That's replaced thinking, okay? And that causes problems. We can make that, we can do better than that.
Richard's got one. How can I tell if I'm over pumping? Well, with a new ModCon, the good thing about these things, most of them, all that I know of anyway, will give you the supply and the return temperature across the boiler's heat exchanger. It's just part of their control strategy, and they also have readout that you can see digitally what they are. And if you're using a modulating condensing boiler and your delta T is any tighter than 20 degrees, you're over pumping. In fact, with ModCons in a central heating call, if we're doing, let's say baseboard or whatever, radiant, we want to make sure that there's times where we can actually stretch the delta T out, right? If we're piping primary, secondary, the boiler can run at a 30, a 35. Sometimes, if the boiler manufacturer will show you that in a manual, you can run it out at a 40 while the system's running at a 20. So just, a lot of that depends on how you pipe it and such, but just look at your gauges. Or if you don't have gauges, just, use your laser scanner, with some tape over the pipe and scan that supply and scan that return. And if it's tight, turn the pump down a notch or 2.
There you go. There you go. Very good. Priz says, I promoted the 0018E and 0034E Plus as the 2 truck stock pumps that you could dial in 95% of most pump issues, residential and light commercial systems, including that boiler pump, home or apartment, up to 2-inch in most cases. Yeah, it's very cool stuff. And 0018E will show you as we go on. It's just the coolest pump out there, in that you can really, with your app, you can see what the heck's going on. So back to how do you tell you're over pumping a boiler? If it's short cycling too. If you have a control on that boiler that tells you runtime and the number of cycles, and you do a little bit of math and you find that your average cycle time is less than 10 minutes, you might just be over pumping. If it's less than a minute, you're definitely over pumping. You're definitely over pumping. All right. You need to check that statement that the separator has less pressure drop than the equivalent length of straight pipe. 6 inches of 1.25-inch pipe at 37 gallons per minute does not appear to be 1 psi of pressure drop. Maybe so, but again, with inch and a quarter pipe, our maximum flow rate's going to be, was it 22
Inch and a
gallons a
quarter
minute or
would be
14? It's 14 gallons a minute in a closed loop hydronic system. Is there a difference there? Maybe a little, to the point where, like you said, no biggie. It doesn't matter. It really doesn't matter. If there is a technical difference, then there is a technical difference. But what you have, the whole point of the air separator is to slow the velocity down so the air separator can do its job. It's big open space in the piping. So if there is pressure drop there, it is, but it's
You almost,
yeah,
it's negligible, right? That means
yeah.
we don't even hardly ever need to consider it.
Right. And James, yeah, you're a geek. So are we. Geekdom is good, man.
Yeah.
There's ain't nothing better than a heat geek.
Yeah.
Oh,
Well,
boy,
it's the
This is
definition of freak, right? My definition of freak. So we're all freaks in here, right? Everybody, hands up, right?
I don't know.
Hey, whoa, wait a minute.
What's your
now.
definition of freak? I'm
Yeah.
not going to volunteer for your definition of freak without knowing what your definition of a freak is.
Some flags fly higher than others. Yes, the freak flag is flying. So here's
Yes.
my definition of freak, everybody. And few of you that have been to my training classes, you know my definition of freak. You go to somebody's house for the first time, not work related.
Mm-hmm.
You've been invited over by friends or family, and it's the first time you walk into that house. After you say hello at the front door, what's the second thing you do?
Can I see your mechanical room?
Yeah, you're taking notes.
Yeah.
You're taking mental notes how the house is heated and cooled, and back in our old job, I'm looking around for fire sprinklers in the house and stuff like that, and if your wife or girlfriend or whoever you came with can't find you, you're downstairs.
Have you gone
Right.
places with either your wife or girlfriend, Dave? Is this what we're talking about, or what's the deal here? How you worded that is strangely specific. No, I'm guilty as charged. Mario, you too, man. That's right.
Yep, the
To the
hands are
point
going up.
to the point where my wife has said to me when we're driving up to somebody's house, she'll start glaring at me and said, "Don't do it. I know you're going to do it. Don't do it. We don't have many friends because of you. All right? Don't you dare ask to see the mechanical room." I go, "Oh, me?
Oh, I've made my wife a freak.
You've made
she
your
starts
wife good for you."
Yeah. Wait, that didn't sound right.
Yeah. Hey, listen. I'm the reason we don't have many friends. I'm glad freely admit that. No, we have a lot of friends. We do.
All righty.
All right, slow down. I think it's time to fold the cards and say goodnight to everybody, guys. Yeah, you're right. Until their boiler breaks, then they're your best buddy. You're right, Mario. You're right. All right, folks. Hey, thank you for this. This was so good to do. I have to set that layoff. This was so much fun. Thank you so much for sharing this night with us. And I really can't wait until next Wednesday. This was really, really a lot of fun. I hope it was good for you. It was a jolly good time for us.
Jolly good.
Jolly good. And
Jolly
we will
good.
see you all next week. Good night, everybody. Good night. Say good night, Gracie.
Good night, Gracie.
Good night,
Good night,
Gracie.
Gracie. There you go. Take care.
Two
everybody.
thumbs up.
Enjoy, y'all.
Enjoy, y'all.
Cheers.